Black Widow. First of all, Robin and I will want to return all the stolen monies to banks A through H.
Yeah, another day, another box of stolen pens.
Have a good night, Homer.
Let's get it on!
See you later, Davey. Marge! Marge!
You're a little late. She's gone to the hospital.
The hospital?
Never too late to go to the hospital.
Shooting for 6.
The man is aggressive.
And in a race against the clock, speaking of which, 30 minutes gone, 30 to go.
Yeah, it is kind of a race against the clock, isn't it? Hey, hi, hello. One moment. Oh, jeez. Okay. I think we're good. I think we've got everything up. Okay, better. Desktop time. No putting this off anymore. Hey, hi. Yes. Sorry, my name is Scott. We normally do ScumVM work on the stream, but we are in the middle of a DOS game jam, and the deadline is rapidly coming up. It is, I think, the start of next week, end of this week. Unfortunately, I don't know, like in recent, like I thought that I'd be able to get the entire thing done. Like both basically we're making an adventure game engine and we're making a demo game to go with it. I thought we'd be able to have like enough time to do both of these things within the time frame, but what I did not take into account was being knocked flat on my ass for the entire weekend, because yeah, just had like a wonderfully persistent headache that did not respond well to ibuprofen, which meant that I could basically do nothing on Saturday and Sunday and very little on Monday. So that has now absolutely thrown my timekeeping into disrepute. So new plan, I think, is that we're just going to try and get the engine feature complete for the game jam, and then maybe we'll take like another week. Just another week. That's still a deadline. We're not giving up. We're not putting in the too hard busk. We're just saying give it another week. It's just 1 week. Remember that. Okay, if I come back like a week later and say just 1 more week, then maybe I have a problem. Maybe I need to kind of get my act together. But that hasn't happened yet. We're still in the just give me 1 week stage of the negotiating. So I better kind of explain where we currently are with getting the engine done. We've done a fair amount of what we need to do. Namely, we've got quite a lot of the driver level stuff working. Like we can draw stuff to the screen. We can, we've got basic classes going for like drawing sprites and background images. We've got a timer system working. We've got event callbacks working. We've got input from the keyboard and mouse going through a polling system of sorts, so we can bind actions to the keyboard and mouse. We've got the threading system working, which means we can have like multiple things happening at the same time in the engine. The main thing that we just kind of need to get now, we've got like all of these kind of like base elements done. What we need to do now is add some more business logic so we can actually do some more adventure game type things in the engine. And we're currently, the roadblock that we run into is the road that we currently run into is pathfinding. So pathfinding, like I've got a little article up here that explains it, but essentially, so like here's a scene in a completely picked at random adventure game that I absolutely did not steal the ideas from. But what you can see here is that you can't just walk all over the screen. That'd just be mad. That would just confuse everyone. Instead, you have these kind of narrowly defined areas known as walkboxes. And that kind of gives, the game engine for each of the different scenes or rooms has a set of these walkboxes set up, which lets it know how to kind of do pathfinding in a very basic way. Like, more modern engines, I believe, kind of, they do like a more complicated version of this where you just have like an arbitrary polygon and then you do some kind of clipping algorithm on that. I'm trying. Yeah, I had a look at that. I decided not to do that because it required like an entire library just to cut the polygon, and that's way too much heft. So what I ended up doing was I was looking at what our good friends at Lucasfilm Games did for their adventure game engine, and it is kind of what you see here. So the walkboxes are kind of implemented as these keen trapezoidal shapes that you can see here, and that, I mean, they're all trapezoids. Even this one that kind of looks like a straight line, that is actually just a trapezoid where the width is 0. So you've just got like, you know, a top left and a top right coordinate that are the same, and then a top bottom left and a bottom right coordinate that are the same. And the engine doesn't care. You can still walk. You can basically just walk on this as if it were a straight line. And like, more importantly, this means that if it's got like a tracing logic attached to it as well. So basically, if the character starts from this point here and I were to click somewhere over here on the screen, first thing the engine would do would be that it would try and find the nearest walkbox to where I clicked. So in that case, it should map to this point here on this box. It'll then trace the path that we need to take based on which boxes are connected to what. So we've got like this box that's connected to that box, which is connected to this box, and which I believe is connected to this, then that. So there's kind of an internal what's called like one of these matrices, which basically says, okay, if I'm at box 1 and I need to get to box 8, what's the next box I need to go to? Oh, in that case, I need to go to box 2. Then if I want to go to box 8, I need to go to box 3. Go to box 8. Then I need to actually go to box 7. And then after that, we're at box 8. So this is how the system should be working. And in order to do this, like essentially what I've done is I've gone into ScumVM, which has a reverse engineered version of what LucasArts did. I've taken the code from that. I ported it first to Python because I actually have a good debugger in Python, made sure that it was working, and then I ported it to Lua, which is what our game engine uses for all the business logic. Now the tricky part though is that the Lua code isn't working. Well, it's doing something, but it's failing. It's failing, kind of catastrophically. Let me show you. Let me show you where we currently are. So, let me just give me a moment to just open up one of everything again. So we'll open up one of these. So this is all of the internal engine code that I've written in Lua. And once we get about halfway down, we get to the walkbox code that I've ported. There's a lot of it. So we can see it goes from like line 211 to line... to about line 700 and... God, it just keeps going. Line 779, so 500 lines of walkbox code, which... I mean, it's still better than loading an entire library just for polygon clipping and having to mess with that. So, but yeah, it is by far and away kind of the most complicated bit of the engine backend stuff so far. And one moment, what I need to do is, because I just turned it off, I need to turn it back on. Yeah, it's here. Okay. So we'll turn this back on. Yeah, for context, this is just a... we haven't got timing and anything set up. I've just set it so that, like, every update cycle, just try and make the actor do a step based on the algorithm. Which should be fine, except the algorithm is a little bit broken. There are two reasons why the algorithm is a bit broken. One is that I probably just introduced a bunch of typos, and just because of how the code looks, it's very, like, I've read it many, many times, and it's very hard to just find typos by reading them. And the other one is that Lua is a bit strange. in that like things like true and false. Like most languages will just kind of agree, like, it'll do its best to determine, like Python will try and do its best to determine if you meant true or false. So like an empty, like 0 is false, none is false, an empty string is false, an empty list is false. Lua, there are exactly two things which are false, and that is false and nil, which is the none, the empty thing. And the problem with that though is that like that suddenly means the number 0 is not false, it's actually true. And if you're not paying attention, then you can cause some real problems with that. Hey DJ Jinx, yes, we're doing it in DOS because sometimes it's good. Sometimes it's good to have creative constraints every now and then. Actually, no, we need DJ GPP, which is the toolchain. I'm just going to rebuild that. Then I'll go into my test game. So here we are. Here's the engine as it stands, and I've turned on the walkbox code, so it is now going to. So like, what's meant to happen? I don't have the walkbox like visible, but there's basically kind of like a C-shaped one up here. Actually, I can show you the. Oh, can I? Can I show you the thing? I think I can. Hang on. I just got to grab. Yeah, so the walkbox that I've mapped out by hand kind of looks like this. So you've got 1, 2, 3, 4, 5 sectors to it. But as you can see, there are some issues. Like, for example, there's just that kind of weird discontinuity when, like, I think the final leg of walking just happens incredibly quickly. So, like, for instance, if I click here, it'll try its best to get through like box number 2, but then once it gets to box number 1, it'll just warp to the end. Hey Thrap, 1981. What's wrong with the AGO SCI interpreters? That's a good question. So obviously AGI, you don't kind of quite get a lot of, you have to settle for some limitations like 16 colors and only like half width graphics and little things like that. SCI, there are custom tools for making SCI games. I didn't really like any of them. They just kind of rubbed me the wrong way a bit. Like, for some reason I just don't develop real. I don't know, when it's just like a custom tool like Adventure Game Studio, isn't it? Like, I tried using Adventure Game Studio once, it just absolutely bounced off it because it's a custom tool and it didn't really kind of make sense. And I know that there's like similar ones available that actually let you develop games for SCI, which is like Sierra's adventure game engine. But yeah, I don't know. I just felt like this would be like a nice challenge. And I guess the other thing is that because I'm actually writing the language, like the scripting layer, it makes more. I don't know. I feel like I can. It's much quicker to just write something than it is to figure out like the proper way of doing it. So, like I'll show you quickly. Like one of the. Do I have? Yeah. So like here's like the code that I'm kind of in the middle of writing for the test game, which I'm probably not going to show too much of, but yeah, like. It's quite nice just to be able to write this out in script. I don't have to worry about like creating objects in a user interface. I can just say, oh, okay, I want to bind like this verb to this hotspot, and then I want the actor to do these things with, multi-threading and stuff like that. So it's so sometimes I don't know. My bet was that it would actually be kind of quicker to. Slightly quicker, not a lot quicker, but slightly quicker to write an engine than it would be to learn how to like be proficient at like, SCI Studio or Adventure Game Studio. What are we doing? Yeah, that's right. Okay, so there's something very off with. So like you can see here, if I click within the same segment, the character just warps there. But weirdly, it's only when I kind of like when I move to the right, there is movement. But it's when I move in the opposite direction that seems to be which causes. Actually, you know what? I have no idea what I'm talking about. I don't know why, but sometimes like one direction seems to be working and then another one does not. And I'm guessing it's got something to do with like the order of which that I'm kind of processing the pathfinding in. But yeah, I have like a copy of all of this pathfinding code, which I ported over from like Scum, the Scum part of Scum VM. And it works fine in Python on the bench when I test it out, but now that I've ported it over to Lua, there are issues. But yeah, we've got text rendering and horrible PC speaker noises, collision detection. Like that part of the engine is looking good. It's just we really need walking. Like I can't. It's one of the few things I can't cut out from the end product. Walking. It's yeah. Also, I need to actually like fill in the drawing frame so that I can show a proper animation rather than just, moving the sprite around like mad. See, that's the kind of thinking that I need for the poll. An adventure game about a teleporting person, like that's the kind of can-do attitude that you're meant to have during one of these game jams. But I lack the ability to do that. I lack the ability to just say, okay, you know what? Let's turn this otherwise massive weakness into a strength, and just say, you know what? You're not supposed to walk. Walking is for chumps. Yeah, okay. So now the tricky part though is that because we're developing in DOSBox, we don't get a debugger, or rather, we don't get like a debugger that I can make work, which means we can't use GDB to debug the C, and we can't use the DOSBox debugger, which is useful looking, but at the same time, couldn't for the life of me get it working in 32-bit mode. And this is a very 32-bit game. So what we're going to do is we're going to open up a telnet session. 00004244.
Song. Press that note to pick that song.
Thank you very much for the follow, DJ Jinx. good to have you on board. Thrall91 says use a VM. Like, that is an option. Like, as in, like, using... The thing is, I'm not entirely sure, like, what the proper debug story is meant to be with DJ GPP, which is the tool chain that I'm using for this. Like, I've seen kind of like some proof of concept things where like there's, you get like a remote GDB stub which you can load into the application and then like access that over like a fake network connection. But honestly, that just seemed too hard. Like there was very little, like, I don't know. I don't like using GDB that much, or indeed at all. So what I ended up doing was I set up one of the fake COM ports in the engine. So COM4 now runs like a fake, runs a telnet session, which I can then use to type in stuff in the Lua command line. So now I can like, if I type in, so like if I go like print ash.x, ash.y, there we go. That's the current position of the character. And if I move the character around, yeah, so it'll also, any print statements that I put in the code will now show up in here, which is kind of good, because otherwise, if you just leave the normal print handler, then DOS will just try and write text to the screen that you're drawing on, which is not good. Okay, so Ono says, doesn't your neck hurt while working at that angle? so like the way I'd say the camera is at like more of a jaunty angle. So like I'm looking directly at a screen which is sort of behind and to the right of the camera. So yeah, I do have to try not and slouch as much when I'm on stream, which kind of hurts a bit, but yeah, you know, sacrifices you got to make. Thrall91 says, just need to get the code working and then create the game. The mouse cursor and graphics you were using reminds me of the old LucasArts adventure game, especially Indiana Jones and the Fate of Atlantis. So, funny you should mention that, because that's exactly where I've stolen the movement code from. So, what I've got here is I've got ScumVM, which is the open source re-implementation of the LucasArts engine. And what we've got here is they've got a little file called boxes.cpp. And in here is like most of the movement code related to things like, you know, finding the nearest point, you know, like all this stuff here. So like defining the boxes, finding the nearest point on the movement thing, plotting a graph between all the boxes. So like this was originally here in boxes.cpp. I went ahead and then converted that to Lua, which is the scripting language that we're using for this game. Like, I guess there's an option to like. The other thing is, yeah, I'm trying to avoid writing C because like the most of this project, I don't know. I'd say like all the drivery bits.
Word level 1. Play but note.
Oh, thank you very much for the follow, Noob. Yeah, like all of the drivery bits are written in C, which is okay. Like it's fine. It's also just, you know, a little fragile and just very, very onerous to do very basic things like writing, like, I don't know, writing a string. Writing a string is crazy hard in C. You have to like do a whole bunch of like extra legwork. Like hash tables, like that kind of stuff. Really hard in C. Incredibly easy in Lua. Hence, we're doing it, you know, we're doing as much as we can in Lua. Double O Noob. Okay, thank you. Thank you for the pronunciation check. I noticed it looks like the screen is elevated so your head looks tilted back, and I imagine that would give you a headache or the back of your neck being sore over long periods of time. Yeah, you're probably right. The screen... Yeah, I don't know. You actually hit the nail on the head. My head does get kind of a little sore over long periods of time. I figured that it, like, the ergonomics wasn't too bad because... I don't know, like, it is at eye level. I'm not, like, straining to look at the screen. You know, it's a fairly neutral position. It just means that, yeah, you gotta sit upright in the chair. But anyway, but thank you for the posture check. Okay, so I think the very first thing we need to do is we need to copy... Actually, let's make this into a bitmap so we can actually see where the walkbox is. And inject this into the game, because I don't currently have that, and that would be useful, like legit useful. Okay, so what we're gonna do is I'll fix the outline on these so that it's all kind of similar.
Yes, I think a series of painful injections directly into Bart's spine should get the job done.
That's right. The Simpsons has a lot of body horror in hindsight. Stroke style? How do I... Oh, wait. Hang on. Oh, I was on the fill tab. Okay, that's why I couldn't see anything. Sorry, there we go. I was like, why is... It looked like the stroke style tab was selected, but clearly the stroke style tab was not selected. Let's change this to pixels. We'll say pixels, 1 pixel. There we go. Okay, and then let's remove these because these are being used for testing. This little tiny thing. And let's export this. Yeah, this thing. Okay. So need this at native res, which is going to be 170 by 170. And I'll just call it walkbox.png. And then what we need to do is take this image and then improve it by removing all the colors, or just dramatically removing most of the colors. So I'll take this image, precision? No. Mode, there we go. Indexed. We'll say maximum number of colors is... Actually, hang on. We're smart about this. We'll go make a different fill. A very different fill. And then we'll go image, mode, indexed. Maximum number of colors is 3. Yep, okay. And then we should be able to overwrite that. Yeah, okay. And now that should be like that. So in our test file, we can go into here, add another bitmap. So we'll go overlay BG. Zero, zero. Oh, and it's got to be above the stars image. So we'll say this is at minus 3, and this is at minus 2. So everything in the scene should be in front of it. Okay, so if we go back to here, kill DOSBox. Oh, I need to set the color key. But there you go. But we've now... Oh, and I've... Okay, the other graphic is kind of in the way of where the top of it is. But we can see now kind of like supposedly where the limits of the walkbox are meant to be. And yeah, like the character's feet is just below the sprite, so yeah, that's something I probably need to adjust on the actor so that it's actually kind of closer to the feet. In fact, we can do that now. Let's sort that out. So the actor. Okay, that's... Yeah, okay, so this figure here needs to be adjusted up a little bit. How many pixels? But yeah, come back down here. And okay, so we're gonna 1, 2, 3, yeah, about 4 pixels. Okay, so we'll make that 76. So what I'm doing is I'm changing the hotspot of the sprite. So the sprite is about yay dimensions, but we can pick a point on it that we just say is the origin, and that's used for things like placement and collision detection and such like that. So I think if we just chop 4 pixels off the bottom, it'll kind of look a bit better. So we'll just do that. We'll start DOSBox again. And we'll just go down here. Yeah, that's much better. That's cool. And yeah, like also it's important to kind of like make sure that the walkbox best represents where you want the person to be. You know, not quite the extremer of where the person can move, but there's like a buffer zone of like 8-ish pixels or so. I'll add a couple more pixels to that just for thing. Also, let's see if we can turn on the color key for that image. What was the... Okay, origin X, origin Y, color key. Okay, so we'll do that. So change this 0, 0, and color key I think is palette entry 0. Actually, what is which color is it? Oh, it's color entry 2. Okay, that'll be why. It's fine. We can do that. So we'll just set that. Now we should hopefully... There we go. Okay, now we've got a crappy placeholder art. Yeah, also another thing that we need to do is get... what's it called? The engine does have Z ordering. You can, you know, display one sprite in front of another. That's how we've managed to get like the background and then this test image and then the character sprite. But ideally, right, when the actor moves to a different quadrant, like that quadrant should have a Z level assigned to it, which then means that like, if I were to turn off interactivity for this test image, then we should be able to move behind it in the scene. But I think, yeah, that's at least kind of, okay. So we're better off than where we were. So yesterday, where I got to it was that, like when you move to a different box, like sometimes the character would just warp all the way up here and then float back into view. We're not doing that anymore. That turned out to be because I'd like mistyped a letter when doing a variable and I copy pasted that a few times, but we don't have that issue anymore. But we do have the issue of like why is it that when going to the left it's instantly warping, but going to the right it's fine even when it's within the same box? Like that's... And yeah, same goes... yeah, so there's something wrong with like negative movement, I think, because like going up is negative and going to the left is negative. So we might have to put in some hooks to figure out exactly why it's spacing out like that. I imagine it'll be to do with because all right, PT actor walk. So we have this function here, PT actor set walk. That just sets it up. That's the equivalent of like saying, hey, this point in the room, I want you to get there by any means necessary. And then we have this function here, which is basically like walk a single, which is basically like walk a single step, if you can. And I'm guessing that something about this calculation is not working when the path goes in reverse. Okay, so wherever I put it, so I put a print statement in here already. I think what we need to do is we need to crack open the Lua shell so we can see the output. So if I move to the right, we get one.
Hello, please press a code
Thanks
number.
very much for the follow, the 32-bit kid. Good to see you. Yeah, so we get one. We get this one print statement here. And I put this print statement here specifically because, like, this is a point where normally it'll just try and interpolate between two spots in space, right? So, like, when you're in the same box, it shouldn't have to think very hard about, like, what it needs to do. Like, by definition, if I click inside the box that we're already in, all you need to do is just sort of edge to, you know, like, step towards there using whatever the step speed is. And yeah, this code here specifically gets called when we ask the engine to figure out what the path is going to be. So, but that code is that's not the print statement that's being called, which makes perfect sense, because this would only ever get called if we're going between boxes. There is another print statement I put in here. A less useful print statement, which I thought I commented this one. Yeah, okay. Which is in calculate movement factor. And that's the one that we're getting in the debug shell. And usefully, I must have done it I must have done it when I was too lazy to list what each of the parameters are. So what have we got? We've got the actor position, the position that it's trying to get to next in the box. These figures here, which indicate, like, how it's related to kind of like the speed and angle that it needs to take in order to get there. Likewise, and then finally we have speed X and speed Y, which is always going to be 8 and 2. So moving horizontal is always 8 pixels per frame, and moving up and down is always 2 pixels per frame. Or, you know, maximum of. Like, you can do smaller amounts if necessary, but yeah, that's kind of the cap. So what I don't understand... So, like, say that we try moving backwards. Okay. So that creates a... Yeah. That calls it, you know, that calls set movement factor once. Moving forward calls set movement factor once, but it actually does a bunch of steps after that. So maybe set movement factor is fine, and it's like this... The stuff that happens immediately after, which is causing it to glitch out a bit. Yeah, so okay, and we're never really reaching this. We're not reaching this branch. I believe it's just kind of skipping over most of this stuff. Maybe it's setting the walkbox, and then coming right down here and calling calc movement factor. And then after calling calc movement factor, it goes actor walk step. So something busted must be happening in here, is my theory. So let's add in some useful hints. Moving to a new... Okay, what is this? I should actually comment this while I'm going. Okay, so what does this code do? It's checking to see if the current walkbox is different to whatever... Yeah, because we've got the concept of like a current walkbox and then the walkbox which the actor has last seen, and then this just... I think this is meant to be kind of the trigger for like when you reach an edge, then this function gets called, which just sets... Like right now all it does is it just copies this ID to here, but eventually we're going to use that to like trigger like a turning animation and stuff like that. So we'll go update the walkbox if necessary. And yeah, like the other thing is that, because yeah, calc movement factor only happens once. That's like, okay, this is the bit which kind of throws me a bit, because like according to this print statement, we only ever call actor walk step like once from in here, so there must be some other part of the code which is calling actor walk step to, because this is the only thing in the walk cycle stuff which can actually move the actor around. So the question is it being calculated wrong, or are we not calling it? Are we not calling it enough, or are we not calling the right spot? Okay, so I think what we were gonna do is let's just add in some more print messages.
Your engine oil pressure is critical.
Thank you very much for the follow, Thrall1981. Yes, good to have you. Good to have you around. Good to keep me honest. Yeah, okay. So we'll go PT actor walk step. Okay, dist y or dist x. Dist y. Because yeah, like this code here specifically is about like sub-pixel movement. Because conceivably, right, you know, we only have like 320 by 200 in terms of resolution. That's not very much, and you'd want movement to sometimes be finer than that, especially if you're like zoomed out or your movement speed is not very high. So there's actually an extra 16 bits of precision used for calculating like how far we've moved, and that's how we kind of deal with, say, like moving in a diagonal line, so that you don't have to like worry about, okay, how many fractions of a pixel do I need to move this frame. You can just track it at like with an extra 16 bits of precision, and then divide by whatever it is, 65,536 to get what the screen position is meant to be. And that's all fine, because we're using 32-bit. Like, you know, 32-bit's great. One of the drawbacks of like Old Testament DOS is that you only get 16 bits, and that is problems. I'm not sure I can kind of quite cope with 16-bit code, to be honest. But mercifully, I don't think Lua runs in 16 bits, so we're fine. Okay, so we've got, yeah, all right, we've printed dist X and we've printed dist. Thrall1981 says 680 by 480, great graphics. Yeah, I know, like that's too rich. That's over egging it. That's gilding the lily a bit too much. 320 by 200. That's what we're going for. I mean, you can ask for 640 by 480, obviously, in DOS. You just need to write a bunch of super VGA code, and I've not quite taken the plunge into learning about super VGA yet. It looks kind of a bit daunting. So yeah, right now we're just using like really bog standard mode. I think just mode 13. Like later on we might change it to be mode X, but 320 by 200. Okay, we've got these two things. Should I? No. We can probably guess if those are bad. I do want to log all this other stuff though, because that strikes me as important. So let us include temp X, temp Y. Do I... Actually, yeah, I want all of this. Hang on. Hang on. Oh, right, okay. Oh, no. Like, maybe this could be the problem? Maybe this could be the problem here. So, like, this code looks fine. This code here, where it kind of... Like, what we're doing is we're kind of trying to check to see if... like, dis.x and dis.y is the amount that we need to move in order to get to the next point from where we are. And that's, you know, an absolute number. So it's checking to see if where the actor is minus what's listed as the current spot is greater than that. And if so, then like this bit here, like when I kind of like think about how it must look, it seems I don't get it. I don't get how it works. So I'm just gonna have a quick squiz at the Python version that I made. Yeah, okay. So in the Python version, I also do this. And I've tested the Python version. I know the Python version works. It doesn't have like the weird snapping issue. But and we're doing, yeah, active Y minus walk data current everything. And walk data next. I think what we're gonna need to do is put one print statement up here which contains actor X and actor Y, or just actor pos containing the position. Yeah, 32-bit kid. Yeah, it does look like a kind of clamp or like some kind of yeah, that's right, like a clamp from interpolating too far. I'm guessing something is up with this like one of these absolute tests, because I don't know. Yeah, because that's got to be why, like, when we try and move in the negative direction, it just kind of immediately triggers this condition here. So like actor X, like either dist X must be wrong or one of these must be wrong. So let's see if we can figure it out. Actor X, actor.y. Yeah, we don't need the fraction stuff. We'll just assume that you know, we can look at temp X and temp Y to figure if that's any good. And then we'll go actor next. Okay, so done that, rebuild this, kill DOSBox, start again. And where did I put my shell? No, that's not the... Hang on. Okay. So now we should be able to look at the shell output and see what we get. So there should be a whole bunch of... So yeah, this is one of the C bugs that I have not fixed. Basically, if the engine, if Lua raises an exception, what's meant to happen is it's meant to kind of acknowledge it, log it nicely to a file, and continue. Instead, we get this, which is essentially, the C part of the engine whinging that it can't find the current Lua stack frame, and honestly, I don't really know how I'm going to fix that without porting the engine outside of DOS to figure it out. But anyway, that's okay. We've only changed like a very limited number of things in the code, so clearly we must have screwed up one of them. I'll just double check. Yeah, it's going to be one of these things. Oh, like that, for instance, like keeping. Like I forgot to call. So like it's whinging that string.format is closed early. So easy solution. So we'll go with that, sort that out. Double check that I didn't screw up any others. Yeah, that looks fine. That looks fine. Give it another shot, I guess. There we go. Nice. Oh, Thrill 1981, you broke it. At least you're using Linux. I use Arch BTW. Yes, this is also Arch. Okay, so if I... Oh, that's right. Gotta open the telnet. 0000 4044. Okay, move slightly to the right. Okay, there we go. So we've got a bunch of... Oh, okay. It's yeah, because I haven't put in a stop condition for the movement code yet, so it's just going to constantly spam the last thing that it's, the last message. But we can see here what it's meant to look like. We've got, yeah, so it calculates these numbers for temp X and temp Y, and it slowly increments, actor walk data, actor new pos. Like that kind of slowly goes up until it reaches actor walk data next, at which point we've stopped moving. So that all makes sense. So now if I do exactly the same thing but in reverse, it's just one step. And that could probably be why. Yeah, that's some kind of overflow. Apparently it's trying to move a mere let's count this. 100,000. Sorry, a million, a billion, a trillion. Minus 7 quadrillion pixels to the left. So it's causing a slight issue. With pathfinding, but that kind of explains why it's immediately snapping there. Okay, so why is tempx all screwed up? Is it the shift operation? Is it just not liking? No, it can't be, because it's not liking one of these shift operations. It would not surprise me if one of these shift operations is a bit broken. Like potentially this shift operation here. I mean, yeah, like there's some kind of overflow going on. Something like I didn't think an overflow was possible, because I'm pretty sure that Lua uses like a infinite precision type integer engine, which is why we can get all the way up to like 7 quadrillion pixels out of out of sync. But let's. Okay, well we know what we need to probe now. So we'll get rid of. Actually, no, we'll leave all of this stuff in here, but we'll add more detail. Specifically, actor roll pause. And then the fraction. And then I guess the delta factor. Scale X and scale Y are fixed, so no point logging them. Okay. Okay. So what have we got here? We've got... Oh. Huh. Why is the old position cooked? Did I type that right? Actor X, actor what? Like, oh, okay. So no, the shift right, is cooking it. Oh wait, no. It's just that the Now, if I read what's going on, so this number is cooked, and oh, okay, I'm reading it at the wrong time. It's probably this. Oh, okay, it's probably this negative number here. Like, I think that's being shifted incorrectly. Like this minus some walk data delta factor, because that's got a shift attached to it, doesn't it? Yeah, okay, so shifting a negative number is just something that you're not allowed to do in Lua, I guess. We'll try. Hang on. Lua. What was the... minus 5,002,4,288. Yeah, okay. Yeah, it's it's not happy about that. Oh no. All right. Oh, Elven Sorcerer asks, what kind of verb system and UI are you hoping to implement? I don't get an opportunity to ask you in the previous stream. It's going to be basically 2 verbs and inventory items. So, pretty much just kind of like down to making it easy to, easy to put together. At least this is just for the demo game. There's no, you can have as many verbs as you want if you're writing the engine, if you're writing a game using this engine. But for the purposes of the demo game, we're basically going to have left click is use, right click is look, and then there'll be an inventory which you can use. You can take things out of and use with things on the scene. And yeah, this is just I don't know. Having tried a whole bunch, like the one that feels kind of the most natural is the one from the Blackwell series of games, so I am nicking it from there. Yeah, 32-bit kid says, that's interesting. I'm not even sure I can tell what it's doing. I'm betting it's got something to do with the variable precision way that Lua implements integers, or like the kind of, shifting right 8 bits and getting that number. Yeah, like I'm guessing that it's just down to, yeah, something along those lines. But that's okay. I think I think what we can do is we can cheat and we can just, because like if we just do a normal shift with an unsigned number, then it's fine. So we'll pay special attention as to whether or not the amount is signed off. Oh, actually though, like technically this could be negative as well. So I'm curious. So if I go like minus 50 and I try and shift that left by 16, 50 by 16, that's fine. So left shift for a negative number is fine. It's just right shift which has problems. Oh, honestly, I don't know if that's actually like a Lua bug or as intended, but that's special. That's real special. Lua is full of kind of, that's an odd choice, but you know, they don't use C. Or sorry, rather it's like at the end of the day, every, you know, minute that I spend writing Lua is maybe like an hour that I don't spend writing C. So through that lens, Lua's pretty good. It's quirks, just fun quirks that I can absolutely live with if required. So let's do the dirty way. Does Lua have a condition, like a one-liner conditional? A one-liner conditional would be really nice. Actually, no, what we can do? We can do like... Okay. I can't deal with right shifting negative. We could just do a divide, I suppose, but that'd be the coward's way out. Oh, but then this would also be cooked because then we have to do a right shift here. Oh, great. Actually, I'm curious. Has someone has got to have run into this. Lua, right shift, negative number. Can Lua do an arithmetic right shift? They're just going to say use it division. Okay. Yeah, use integer division instead. Okay. Yeah. Lewis seems to have done a logical right shift instead of an arithmetic one. Okay. You know what? I'm going to take the coward's way out. I'm just going to do an arithmetic to right. I mean, yeah, we've already kind of crossed the I don't think doing one divide in place of a shift is going to meaningfully change performance that much. So okay, so a right shift by 8 would be an integer division of 256, I think. And this would be an integer division of 65536. Okay, now I'm paranoid. Do I do a right shift anywhere else in the code? Huh, okay. Only left shifts. But that's okay. But as we've proven, left shifts are okay. So yeah, okay. That, you know what's probably happening, right? So say that you have like a big, or say that you have like a negative, like a 64-bit negative integer, and it's in two's complement, and you do a right shift operation on it, like a literal right shift operation will move the sign bit with it, which means you'll just get like a crazy high number. So, whereas if you shift to the left with a 2's complement number, the sign bit is probably okay. I think that's how it works. Yeah, okay. Well, actually, is it okay? Like, can we construct a number where that isn't okay? I think that we might be able to construct a number where that isn't okay. If we really tried. What was the, like this number here? So if I were to take... Why am I not like... Why is the mouse being weird? Why can I not, I can select in here, but not... Oh, it's because this junk was running all the time, so... Yeah, okay. That's why I couldn't select anything. But what I was gonna say is like all the way down here, if I take one of the giant numbers, like this... And we look at it as hexadecimal. Yeah, okay. And then what have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I were to take that and then... Okay, but I mean that's yeah. Like, if I were to go like, oh, what's this number? 191. So in theory, right, if we did... I was going to say if we did a left shift operation, then that would kind of... That might break left shifting, wouldn't it? Because we would no longer have... Like, if we did... yeah. Because if this was the sign bit and then we shifted that out, then it would suddenly be a positive number again. And that might not be good. So... I am tempted to say... Shifts. They're bad news. Get rid of the shifts. Okay, yep. I'm just anticipating, like, other things that could go wrong at this point. Do I have any... Oh, yeah, okay. That's a shift. That's a shifting. Get rid of the shifts. Okay, shift's gone. And I could probably start commenting out some of these print statements, but we'll do that after we confirm that. Yes. Okay, it's slow because it's currently trying to buffer everything to the command line or the debug console, but pathfinding seems to work. Sort of. Actually, no, that's right. It's cutting that corner, so that makes sense. Yeah, 32-bit kid, like, it does kind of feel like the left shifts would be okay. I'm just worried that, like, in the naive case, like, in theory, there is a threshold where, like very close to, like, the negative number limit, where if you were to shift left, then it would become a positive number again. Because you just wouldn't have any bits to become the sign bit in 2's complement. But anyway, okay. let's go through and let's just go through and get rid of all these print statements. Because we do not need them anymore. They're just slowing us down. Okay, so rebuild this. Yeah, okay. And yeah, the movement ratio kind of looks a little weird because we've deliberately capped vertical movement to be like a quarter of the speed of horizontal movement. It is going far too fast because it's rendering as fast as the engine can go. Like ideally, I think what we'll do is we'll set the frame rate to be about 8 frames per second for the walking animation. But I'm pretty happy with that. We've got the pathfinding algorithm seems to be working as... Oh, actually, okay, there's still some things that could be improved. Like, for instance, me clicking down here in the void of space, that should be, you know, it should be trying to match that to the bottom of the walkbox, not the top of the walkbox. Whereas, like, it's always trying to match the top of that walkbox for some reason. Like, why is that? Why is it just aiming towards the top? Like... And again, it's directional. Like you can see here that if I click like here and then I click offside here, oh, okay, like that makes more sense because it'll try and wrap around. But if I click down here, right, why is it sticking to the top? That doesn't make very much sense at all. So maybe in my hubris, I shouldn't have deleted all those print statements. Maybe... Okay, let's pretend that I didn't delete quite as many print statements. In fact, let's put them all back and then comment them out. So, God willing, we can check to make sure that we're not doing the right thing. Okay, so this is in... So, we'll comment this one out. We'll keep that one. That's mostly useful. These are all commented out. These... Yeah. Yeah, omnifidus, yeah. I have a similar problem. Right goes to left and up goes to down. I think it's more just that kind of like if you try and aim for points that are... If you aim for points that are negative outside the walk box, it'll snap to them. Or like... Actually, I mean, like, to the right is fine. It's just to, like, negative Y values it doesn't seem to really like. But, like, to the right is fine, and to the left seems fine. It's just to the bottom. 32-bit kid says, that feeling when you remove all your debugging and there's still a bug, yeah, it's one of those life's many joys, isn't it? Which is why I'm thankful for having an editor where you can just undo with a single button press. God, yeah. Imagine doing this with like actual of the era DOS, like code editing and stuff. It would be considerably less enjoyable. Okay. So, going back to here. I want to say the issue would be to do with this function here, right? Like this is where I would guess that it would be. Because like the very first thing that happens, right? Like I click the mouse Do I have the code up here? Yes, I do. So here is the mouse handler event I've written in the game code. So it's basically, it'll click the mouse, it takes like the X and Y position of the mouse, it will then try and match it to a hotspot ID. So at the moment, like, this is really the only hotspot in the room. And if so, it'll set a walk to the hotspot position that we touched. Otherwise, it will just try and call actor set walk with the coordinates of the mouse. And that's what happens whenever we click just like out in empty space with nothing there. So what's meant to be happening when that happens, right, is that it takes those two coordinates and then it'll try and adjust that point to be in whichever one of these walk boxes is closest. Like it'll go through all the walk boxes, test to see which is the closest one, and then, you know, based on that, it'll go ahead and like set up all these variables for like the walk routine. But it would make sense, right, that if we're clicking the mouse like down here, and then for whatever reason this this function here says, oh yeah, you want to be in this box but just on the wrong side, then that would potentially be a problem. So let's put in some debug statements for adjust point to be in box. And yeah, that also builds on like two functions, checkpoint in box bounds and get closest point on box. Clearly get like checkpoint in box bounds is working, I'm guessing, because it's able to figure out that we're outside the box. But it's this fallback feature here which seems to be screwing up. Let's just put in a quick cheeky breakpoint here for this. Actually, I'll also turn this off, which then means I can call it in the terminal. So we've got that. We'll go best point D box D. So I think this should give us a base level information. Okay, so rebuild that, kill this. So like, here's an example. So that works good because, you know, it's figured out that it's in box 1. It's figured out that the best point is completely inside the box, and then, you know, it moves as expected. And if I click to the northwest of the box, it should figure out that, yeah, okay, so it's got the point that I put in. It figured out that the best point is the top left of the box. That's all good. Now what if I click underneath the box? For some reason, it has picked best point at the top of the box. That is incorrect. That is absolutely not what should be the case. It should be picking, like, whatever this point here is. It's like, hang on, not millimeters, pixels. So 22 by 136. So this bottom row is all y equals 136. But it is not snapping to any of that. So, PT get closest point on box is doing a bad job. Now, what's to bet that it's because I made a typo when I was porting all this stuff? I mean, it might be that, or like there's really not a lot to this function. It does rely a bit on this closest point on line feature. Let's make these unlocal. Like if I had to guess, like maybe it's in here that we've made a mistake. Either that or like this comparison logic is very subtly different and I didn't copy it properly. I mean, it looks pretty much just like it's checking the... Oh. Yeah, okay, I'm... okay. Yeah, so the problem is that we're only actually testing one side of the box. We're just testing the top side. The others, we don't actually bother calculating this number here because I forgot to include it. So, surprise, the top line always wins because it's the shortest distance. So that's a mistake. That's an easy mistake to make. Yeah, that's right, Dr. Buck Doctor. It's optimized. Like this is basically Carmax inverse level optimization we're talking here. You only need to ever check one line. By definition, you can't be wrong because there's nothing to disprove it. Anyway, but assuming that we want to kind of like talk about boring non-optimized code, we've still got some slight residual weirdness with the pathfinding. Oh, but then again, like it's residual weirdness because like the closest point of the box is here, and I was like going, why doesn't the character snap to there? Answer is it's not closer compared to the straight line distance from that box. But yeah, okay. We seem to have movement seems to be working pretty well now. That took way less time than I was expecting, but nice. Good stuff, good stuff. All right. I think we can tick that off. We can tick that off the list of stuff that he's doing. So, nick the box-based pathfinding algorithm from ScumVM. Yes, we've done that. Next job, synchronize up the walk cycle timing. Okay, that shouldn't be too difficult. That should just be a case of messing with how we currently do the update part, like the animation update part. First things first, though, let's get rid of the print statements for real this time. I think I've turned them all off. Yeah. Oh, and I should make those make those private again. Yep, that'll be private. That'll be private. Hey, Racing the Beam, how's it going? Yeah, so for context, I'm just adding local in front of all these methods here, which aren't going to be part of the public API. They're just used by the backend stuff. But oh, feels good. It feels good to have working pathfinding. But yeah, it's it also feels good to have like a working debugger which you can use to to probe these things. Oh, just like doing this without. Race of the Beamo says, does Lua work in DOS? It sure does. So we're building the engine with DJGPP, which is a DOS port of GCC and like some but not all of POSIX, which means you can like Lua is just it's straight C, so you can build it with DJGPP. And in this case, what we've done is we've got like the engine that we're making we're making an adventure game engine for a game jam, a DOS game jam. And the intention is to basically write all the drivery bits in C, and then the actual business logic part of the engine, that's all going to be done in Lua. And like if we can look at like the interface between like the C bit and the Lua bit, it's very small. Like here, like these are the functions that I've currently like exposed between C and Lua, and they're pretty much all, I don't know, they're all kind of related to like drawing in some way. So like image loading and image blitting, like that's all done in C. Loading the fonts and rendering the glyphs, that's all done in C. Checking image collision, and then like there's a few which just kind of bind, like, you know, getting events, like that's all coming from like the driver code from the mouse and the keyboard and such. But all of the actual fun adventure gamey stuff is done here in Lua, which is to say like everything to do with like, I guess like setting up actors, getting them to move around. We just, you know, this walkbox code that we fixed is all in Lua. Queuing up the right animations and stuff to play. But yeah, we can see here like the very basic test game that I've got we've got like collision detection turned on. So when I move the mouse over this sprite, you can, you know, it gets this little status message saying what it is. We can click on it to trigger a verb. So if I click on this, the sprite will try and move to it'll move to the hotspot that this sprite has, and then do the action that I bound to it, which is to say something. But there we go. Oh, and then play an awful noise. But interestingly, like here's an example of like something that we need to fix with the multi-threading. So you can see here that like, because like if I started all the way over here and then I clicked the image, it'll just keep doing the walk thread while it's waiting for the action thread to happen, when in reality what you want to happen, right, is when you click on something for there to be like a walk action queued up, and when that finishes, then do the you know, the verb action, if that makes sense. So that means that if you're just kind of like lazily like just clicking around, doing whatever, like as long as you don't actually make it to the spot, it won't actually go ahead and do the verb. It'll just override it with whatever you clicked on next. So yeah, a few little kind of things that we need to fix. So okay, next thing that we kind of need to look into, I think, it'll be either the timing. So I'd say like the timing of the walk cycle. I don't have multiple walk animation frames here yet. They're not quite ready yet. I've sketched them out but not filled them in. But yeah, we need to get the timing right so that the walk animation, or you know, the steps, like each of these steps is currently unbound, but it should be about 8 frames per second that we're moving around. And then I want to fix up Z positioning so that it's possible to like walk behind this item here. And then after that, we got to fix up the timing so that it only triggers the verb action once you've walked to the spot. So I'm just going to write that down so I can remember it. So we'll say Add animation timing to walk. Add Z repositioning to based on current walkbox. And the last one was force a delay for a verb action until we have stopped moving. I think that should be enough, because as you can see here, like part of the mouse down code that we've got here, like it will set the current verb to be, use whatever the hotspot is, until I click just somewhere on the screen, at which point it'll just be zeroed out with nil and nil, which is the equivalent of just walk. So I'm pretty sure that means that, like, if we do it like this, then clicking somewhere else that isn't the hotspot with the action will mean that it'll get cancelled out, and we don't need to like intercept the thread or anything. We can just let it live, let it exist. Okay. All right, animation timing. Yeah, so current routine, dumb as rocks. It is at the very end of the event pumping cycle. It'll just try and update whatever, it will just run this update room command, which will go through to all of the actors and try and make it continue doing the walk cycle. I think that what we will need to do here is adjust this so that there is a timer. There is a timer on the actor, which we can set. So something back in, where's the actor code for here? So we'll just say like Ash walk rate, and we'll call it 8. And then this will be the effect. Yeah, that'll be like the effective frame rate for walking. Yeah, I think that'll do. I'm in two minds about whether or not we should just put it as a delay or if we should put it as a rate. I think we'll just keep it as a rate for now, because that's not too difficult to get the milliseconds equivalent from. So by saying that, we'll basically be saying that, like, we want the actors to take a step every 8 times a second. And okay. So in here, we'll have to add some more stuff, and we'll go. We'll say the default walk rate is 8, but so we would then need to go, how do we do it with, so like by comparison, right? If we look at the threading code, we have, we just keep track of how long, how many milliseconds till the next time we need to update. And I think we do something similar on the animation. yeah, like we've got a rate, and then this is how we kind of calculate the. Okay, there we got like. Okay. So then we'll just go like walk data next weight equals 0. Yeah, okay, and then we'll just update this parameter for the time when we need to wait for the next walk thing. Okay, so then back up here to that. We'll just basically go if how do we do it for and then we go and there's probably going to be like a whole thing where we need to synchronize it up with an animation object for the frame changes to make any sense, but we can worry about that later. Actually, no. What am I saying? We can go if actor moving greater than 0 and yeah. So we do this, PT actor walk actor, and then actor walk data next weight equals PT get millis plus 1000 divided by also this should be an integer divide. Okay, so I think now that should mean that we move at 8 frames a second, regardless of the rest of the engine speed. Oh, and I made a mistake. Wait, did I? Oh, 892. Okay, yeah, I just pasted some junk. Nothing to be too concerned about. Okay, there we go. It's definitely looking kind of a lot choppier. That makes I'm hoping that it will look kind of less less dodgy once we put some animation in there. I think that might be a case of like, you know, tuning the rate to see what feels the best. But multi-threading still seems to be working, which is the important thing. Okay, so we've got that. Now I guess the next thing would be to yeah, it would be to fix the Z positioning. We can absolutely do that. So what is the current Z position of that? That's kind of, yeah, it's a little annoying that this is so big. Or maybe kind of the walk path is too small. I haven't decided, but But yeah, like ideally what we want is we want it, yeah, so we want this sprite to be just kind of here smack in the middle, and then you can walk around the edge to get there. I mean, that's doable. I mean, like, you know, we can just use the extremer to say, okay, walk to this side of the walk box. Huh. Is that the dimensions of the... Yeah, I guess it is. I guess it's a big old wedge shape. We just can't see it because this is in the way. This placeholder's in the way. Okay, so let's nudge that placeholder down. Nudge that down. What have we currently got? So we've currently got it set at like 32 by 32. I say nudge it down another 16, so that'd be 48. That is currently at Z position 0. I think really what we want is, let's say this is at Z position 1. Let's say that the DOS smells mural is Z position 1, and then we should be able to adjust things so that these top two are Z position 2, and then yeah, that's what I mean. So just go 1 0 0, which means we'll then need to, actually, is that right? Because negative is further back, positive is further forward. Yeah, that's right. Okay, yes. So 0 would be about right. Then we have to think about like the background image. Okay, so the background image is at -3. That walkbox image is at -2, so it shows it in front of that. So yeah, we should be fine. That should do nicely. And then now all we have to do is go back into here and adjust the code that happens when we change walkbox, which has a name that I said like an hour ago and I've forgotten which one it was. It's not pathfind towards. It was not walk step. Calculate movement factor, I think might be it. Because that's the one that sets what the next... Or maybe we should just go for... Okay, like this is the method here which sets what the next box is going to be, or it finds what the next box is going to be. Actually, what am I saying? We just use PT actor set walkbox. Because by definition, that's what needs to be called when we move into the new walkbox. And I've already got some code here which sets it in the Z position. So maybe it's already working. Maybe I fixed it when I was sick and I just forgot because of how broken everything else was. Or maybe not. Okay, so we can see here that DOS smells is kind of in front of the character, and then if I move up here, it's still in front of the character. Is that down to... Why is that? Why is this persistently in front? Did I hit save? I did hit save. Actually, no, hang on, let's do some tests. So, okay, you move over there. I'll open up Telnet. And then ash.walkbox. Okay, so it's it's correctly identified that we're in walkbox 1, which has a Z level of 2. And Ash's Z level of 2. And if I walk back up here, I check Z, yeah, okay. So we are changing Z level based on where we are, but the rendering order is still a bit cooked. Which I have a feeling is probably because of something that I did. Some kind of terrible decision that I made. Okay, so we have this separate carve out here for the mouse, because pretty much the mouse cursor always needs to be drawn on top. And then we just check the room's current render list and then the global render list. Is it because one of these two things, I mean, if the test image was in the global render list, that would be a problem. But I'm pretty sure I added to the room. Test PG. Yeah, I add the test background to the graphics room. So what's the deal? Why no work? More probably, where did I put the telnet? There's the telnet. It's here. Okay. PT get current room, or just PT current room. And this is the render list. Oh, it's okay. There's probably like some kind of recursive relationship, which means that it's just showing everything rather than just the thing I want. Huh, no, it's just ignoring the second part, which is weird. PT. There are some weird bugs with the Lua console that I need to figure out. Print PT current room. Okay. So we've got the background, the star background. We've got the walkbox background. We've got the actor, which should be at position Z. Yeah, Z pos is 0. And then we have the mural, which is at Z position 1. So why is it drawing one over the other? That doesn't make any sense. Oh. No, maybe it does make sense. It makes sense because the list is ordered, and when I change Z position, I don't update. Yeah, okay. I don't call the ordering thing. That'd be why. And box Z doesn't equal actor.z, then do this, and PT room what is it? It's like it's like global add object. Okay, we'll just call PT room add object again to sort that out. Okay, we can do that. There it is. Okay, so here we go. Look at that. We've got depth. We've got depth. Oh man, this is... To put things in perspective, like, just to get the walk code this far, it's taken like 2 nights. 2 nights of like smacking my head against it. So to get like all these little kind of... These little wins within 2 hours, very satisfying. Oh, sorry, Dr. Butt Doctor. I think that it's the wrong. You got the wrong stream. I think I know who you're trying to channel there. So like, but I think this works.
I dreamed I was married to Corey and we lived on a pony farm. And Corey was always walking around with his shirt off.
There you go. So it's okay. There was still one print statement, wasn't there? I better turn that off. Yeah, this thing's gotta go.
Dried scallops, which were rehydrated, boiled bamboo shoots, Japanese peppercorn, mustard, mayonnaise, and shichimi hot pepper spice.
Love a bit of mustard mayonnaise with my spicy peppercorns. What are we doing? Okay, so animation timing done. Z positioning done. I think now. Did I commit? I don't think I committed. I better do that. Let's do that. Okay. Boot. Walk. Code working. Oh, dang it! Hang on. I have automatic code formatting set on, except for some reason it doesn't seem to be really running. I have to like force it to pay attention. So yeah, you can see now it's gone ahead and like cleaned up my my dodgy multi-line nonsense. But that's okay. Okay, so I've got that done. And this delay here, okay, I think we can choose this because we've already got similar weight codes for other actions. Yeah, like, okay, so here we go. Here's currently the method that gets called by the event updating code to check to see if there is a verb that needs to be actioned. So like down here, right, in our game code, we've got this mouse down handler. We've set it so that like if you click on something interesting, it'll call this pt do verb. And all that does is that just kind of like puts, you know, it just kind of like sets a flag saying, hey, we've got something to do. So like all it does, it'll just, yeah, it sets the current verb name and it sets the current hotspot ID. And then, you know, so then like a bunch of other stuff happens and then it gets up to the event updating cycle. And then it calls this guy here to check to see if we've got a verb action that we need to do, and if so, do we do it or not? So I think that we would just need to add. So we've got a choice. We can either make this like a custom, like something completely custom, like something that can be overridden by the game author as opposed to like here in the engine code, or we can just assume that like when someone clicks on something, they will always want to walk there. I'm not sure if that's necessarily, because I mean, realistically, right? All we would want to check here is like, is there a verb that's currently been queued up, and have we stopped moving? And have we stopped moving? That feels like something that we could just, we could very easily make a function that gets exported from the engine, and then can be called in the, then from the game side we could basically just be like, set verb ready callback is this. In fact, I kind of like that idea more. Like, it wouldn't be too difficult to kind of to wire up on this end. So it would be something along the lines of like, because we've got currently like, just so it'll be like PT on verb ready function, and then it'll be basically like, oh no, it wouldn't be on verb ready. It would be basically like check verb ready. Do I have like a, okay. I'm just conscious of like having a very consistent naming scheme for this API, so that it doesn't, that I don't. Or we could just go PT verb ready check. Or set verb ready check. Like, we've got set watchdog limit, set mouse sprite, set auto clear screen, set image origin. I should probably change the set image origin one, but that's okay. We'll just go set verb ready check, and then we'll go return ash.moving equals 0. And then on the engine side, we would just need to go all the way up here in our verb code. PT I was like, verb callback equals nil. Yeah, it looks about right. Okay, so we've got that. Then we'll just go PT set function callback there we go. So it's not going to work because of initially, because there is one other thing that we need to fix about the movement system, and that is that, like, even after kind of like moving to a particular spot on the screen, we can see this in the telnet. we don't ever set moving to 0 at the end. That's something that we need to fix. Because otherwise, yeah, the character just kind of so like I'll set up like if I set up like movement like all the way over here, and then I go Ash stop moving, we can see that it's like it starts off as 1, and then by the time it reaches the end, it's 8. 8 basically means we're in the very last walk box, so it's like straight line movement. 1 I think means we've started we started walking, and there are 2 other numbers which I think are related to turning, which we don't have implemented yet. But yeah, what I think we need to do is we need it so that when we've stopped moving at all, then we set it to 0. And then that would be when Ash when Ash X and Ash.Y are the same as this figure here, which would be yeah, so that would be the same as walkDataDes.x and walkDataDes.y. And I believe yeah, so the place where it's kind of meant to stop it is I think I don't know. This code is kind of a bit of a mess because originally it was a bit mask, and then specifically because it broke things, it's now just been triangulated to be like a straight value like this. But I think that like okay, so assuming that like we're at the very end and it's going to be on last leg, which is number 8, it first checks to see if moving is 0, then it returns. It checks if it's not a new leg, which is true. It will call PT actor walk step, which does all this kind of like fractionated movement. And if it's true, then it will hit return. And I think that that's where we're getting... That's probably where we're getting sidelined. That's tricky though, because technically that, I mean, we do want it to short circuit here, but ideally we probably want to kind of add in a check for I guess we could probably just go like, we could just do a manual check of like, if actor.x equals, or if we go and we just manually check for those parameters. Walk data desk, that's it. Okay, and that should stop it for us. 731. Did I? Oh right, I cocked it up. Sure, why not? So there we go. We can now move around. And there we go. It's resetting it properly now. So ash.moving. Ash.moving. Brilliant. Okay. And I think with that, that means that like if I were to move to down here and then, well, like all the way back down to here and then click on the mysterious image, it should wait until we walk, you know, wait till we get to the end of the walk cycle, then it will trigger the action. And if I were to move over here, then click this and then yeah, it cancels it. Okay, sick. I think we've done it. Okay, brilliant. Cool, 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 cool. So that is done. For right. Okay, that's basically all the movement stuff that oh okay. I forgot one other thing. One other kind of important thing. Camera. I mean, like right now, this test scene, we can see the left-hand side of it. But if I were to actually like open up the bitmap that we have, we can see it's quite a lot wider. And yeah, what we really need in order for that to work is we need some kind of automated tracking dingus that can well, two things. It needs to be able to kind of keep track of where we are and kind of nudge the camera based on you know, like there are two options. We could have it so that it tries to like always get you in the middle of the screen as much as possible, or we could set it so that there's kind of like a dead area like in the middle, and then as soon as you kind of like move out of that dead area, it'll try and like scroll up or down or left or right, or however much canvas space there is. Yeah, and then that introduces another kind of wrinkle into the rendering system, which is that suddenly you need to be able to have everything rendered relative to the camera, which would just mean changing the positions that we send. Yeah, change the position that we send when kind of drawing it out to the screen. Yeah, that too, Dr. Buck Doctor. Yes, very true. We need to kind of like, you know, suddenly things like clicking the mouse on the screen have to be redirected through, you know, transformed based on what the camera is. So the little kind of hack that we had before where just getting the mouse event, we would need to have a way of basically saying get room coordinates from mouse. All not too difficult to do. I'm feeling hesitation in doing it, but at the same time, that's probably a good sign that I should probably do it. Otherwise, I should do it now, specifically. Otherwise, it'll just kind of like, just sit there not being done until it becomes too late. And, yeah. after a while, you kind of you get used to the idea that like if you suddenly think about something, it's like, oh, do I have to do it? Can I put it off? It just that's generally the thing that you should really just try and fake some momentum into doing so that it can get done quicker. Yeah. Otherwise, I'm one of those people who definitely falls into the trap of when a problem like that comes along. It's like, a problem which has like many sides and many right and wrong ways of doing it. I'll just sit here for like 4 hours trying to think it through before I make like the first incision or whatever, and that always takes longer. Like without exception, every time that I've tried to think something through, it's been worthless, and I should have just started and forced my way through to the other side, and it would have taken less time. So, with that in mind, what have we currently got on our room structure? We've got a virtual width and a height, so I did remember to add that. We don't have the concept of a camera though, so I think we're going to have to add one of those. So we'll add in like camera X, camera Y. All right, first question then. Like, so we've got camera X and camera Y. Where do we consider the origin is? Easy solution for that is that we just add an origin. Like that lines up. Like all the graphics that we've got, for instance, in the engine have an origin field, which allows it to... Dr. Box says, can we scroll up and down as well as left and right? There is nothing stopping us from making that happen. I'd say in this particular example, like the image that I made is only wide. There is no picture on the top and bottom to scroll. But yeah, like we're not doing any kind of fancy tiling algorithm or anything. We're just, I want to say, yeah, the drawing code in this, not optimized at all. It is just drawing as quickly to the screen with Painter's algorithm. So in order. Eventually, what we're going to have to do is we're going to have to add in dirty rectangles. So essentially going in and setting it up so that we only redraw the areas of the screen that have changed. And then after we do that, we can then like look into other optimizations like double buffering. The world's first open world DOS adventure game. Come on, someone must have done that before. Like, wasn't there like I was gonna say like Sierra's like Imagination Network or Habitat? Habitat. There you go. Like Habitat wasn't for DOS, but it was open world. And it was an adventure with friends. But yeah, if we wanted to make like a remake of Habitat in this, I guess yes, we could have scrolling up and down as well as left and right. Although I think Habitat was also just scrolling left and right, because that was like based on Maniac Mansion era technology, which did not have vertically scrolling rooms. But anyway, I think what we're going to do is we're going to have X and Y. I think, yeah, we've got origin X and origin Y. And then the way this will work would be that origin X and origin Y will be in screen coordinates. So most of the time we just assume that like origin X and origin Y will be like smack in the middle. So like 160 by 100. And then the camera movement code only has to worry about which, and then X and Y will be like in terms of X and Y will still be in terms of room space, which will be kind of like the entire, the entire virtual room, but we would only have to worry about positioning the camera based on this. I think that'll work. Yeah. Yeah. Maybe. And then, okay, so if we say, we'll make some kind of, some sloppy assumptions. So we'll go screen width divided by 2, screen height divided by 2, and then we'll go like, so yeah, maybe that's good enough. Maybe it's good enough to just have this in the room. And then I'm thinking more in terms of like, how do we implement like dead areas? Maybe that should be down to the actor. Maybe, oh no, maybe the room. I don't know. Because I'm thinking like, where in the stack do we set it so that like a camera move is only triggered if you kind of go within a certain part of the screen? Actually, you know what? What am I saying? I'm overthinking it. We can add that in later. Don't need it now. We just need... The thickest possible option will be just to try your best to match wherever the sprite is to wherever the origin is. Like that seems the most sensible thing. Okay, so now we've got those values, and if we look all the way down here in the renderer bit of the code, we've got all the stuff here which will try and draw an image if it is visible. And it just does this based on the X and Y position in... It just does it based on the X and Y position. So we're gonna need some functions to convert between screen coordinates and... Yeah, we're gonna need some functions to convert between screen coordinates and room coordinates. So we'll say like, do I want to call it point? Yeah, I mean, we've called it point and a bunch of other things. Like, I feel like... Yeah, okay. So we'll call it room, X, Y. Here for the new term room space. It's got legs, Dr. Buckdog. I think, yeah, I think it'll catch on. Oh, you mean like we could call the function like room space to screen space? Yeah. I don't know, maybe. Plenty of time for renaming things later. We must press on. So we'll do the other. Actually, we'll do the screen one first because that's easy to conceptualize. Screen point to room point, and then we're gonna have to add in a type check. We mean to look into typed lure because that sounds like it might be kind of nice to have, but I'm guessing that it doesn't give you the actual. It just does like compile time checking, not verification, which I think is probably nicer if you're an engine if you're making a game to get the engine to tell you that something is wrong. Okay, so we've got that. And then we'll go return. So what do we have? We have so if the origin is like smack in the middle here, and X and Y are at I mean, they're technically not going to be at 0 though, are they? They're not going to be at 0 though if we consider that. I mean, no. No, they are. They're going to... Yeah, because like this may be kind of not quite enough. Because I'm like just thinking in like this situation here, say that with just, one screen like this, like by default, I want that to like, yeah, I want that to kind of be neutral. So like if we're thinking about like how the camera slides around on rails, like does it make more sense for it just to be in the top left as opposed to the middle? Is that kind of like over-egging it? But no, it doesn't make sense as soon as you start thinking about like the open world case where like the image is very, 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 very big. Because then you want the origin to just be in terms of where Muggins is standing. Or you want X and Y on the room to be where Muggins is standing, and then the room to just kind of come from that. So maybe we actually need a wrapper function to like get the current. Yeah, Dr. Buck Doctor says the origin at the center would make some things easy, but then you have more negative numbers. Negative numbers not necessarily a bad thing. It's more just in terms of it's this X and Y. It's this like, and I'm worrying about it because we don't currently have anything that sets these, so it's hard to visualize like, because like in a perfect world, right? Because we've set the width and the height of the room. Like, during the update cycle, X and Y should be constrained to be within, like, a possible dimension that it will fit, if that makes sense. So, if we're talking about, like, a room that is, like, too... say the graphic doesn't reach the whole way up, it should be centered vertically. And, like, for the cases where you don't want that to be the case, just pretend and make the graphic bigger. But, use the right spot. But whatever process is responsible for updating X and Y will automatically snap it to the one valid spot, which is smack in the middle. If that makes sense. So then, when that happens, we can just assume that ignore this. Ignore this X and Y being 0. That's never, in practice, going to happen. We can just assume that they're always correct. Which then means screen point to room point doesn't have to do any, it doesn't have to assume that this could be wrong, is what I'm getting at. Like, if we've got something else which is updating this, and that's considered correct, then this can just go, oh, X, we've got a room. X and Y must be you know, this minus that offset. So yeah, okay, that makes sense. So then literally it would just become like room.x minus room.origin.y. Sorry, origin x. Okay, screen point, sorry. So it would be, so this would be your screen dimension. And this would be the top left of the screen. That's what this is. This is the value of the top left of the screen. So ergo, this minus that plus this should work. Room y minus room origin y plus y. And then we can do the inverse for we'll just do screen to room, and then we'll go room to screen. And then it should just be the inverse of that. So it would be would it be the inverse of that? So like, yeah. So room coordinates to screen coordinates would be okay. Okay, so room x minus room origin x, that is the top left of the screen in room coordinates. So if we have a room coordinate, which is x, and then we minus this from that, so then, you know, if our room coordinate is here, and then we have the one that's for the, yeah, the ones for the top left of the screen, yeah, that makes sense. That makes sense. And then, like, that still holds, doesn't it? It's not, because, yeah, I think that holds. I'm not sure if this is like minus though. Would this be minus? You've got the top left of the screen in room coordinates, which is here. And you've got this in screen coordinates. So no, it would be adding. It'd be adding, and then this would be subtracting. I think that makes sense. Okay, so we've got this. We would probably need to add. We need to add in update room. We would go so we'll just go like constrain camera to bounds. And then how would that look? It would essentially, okay, it would essentially be room X equals math.min. Yeah, we're going to do a clamp, math.max. So like, okay, so this lowest would be, I guess, okay, so clamping logic. Okay, we've got to do some more maths. So say that we have like an image that is 180 pixels high on the 200 pixel screen. And our origin is smack in the middle of the screen. Then that would mean that like the coordinate would have to be, I mean, it would still be in the middle though. It would still be in the middle, but so we'll go room height equals 180, screen height equals 200, origin y equals 100. And then yeah, we just need to kind of figure out like what are the valid range of like y positions that we can fit on the screen. Fit on the screen with the information that we have. So it would probably, okay, so we've got the screen height, which is 200. What if we said like what if we said the room height was 400 to begin with? Let's deal with the kind of the sloppy one. And then we would say, okay, we would then say like the minimum y min would be y minimum would probably be origin y. And then y maximum would be room height minus origin y. Yeah, because you can't go any further than that. Oh, but I am assuming symmetry here with the origin, which is not technically true. So it should actually be y max equals room height minus screen height plus origin y, which is still 300. Yeah. Okay. So that makes sense for the big case where the room is bigger than the camera. But in the small case, then we have to start thinking about other things. So yeah, like if room height is 180 by contrast, then y min and y max should be the same, which then means that like, so like if I try like room height 180 minus screen height, which is 200, plus origin y, which is 100, we get 80. So this has to, so actually we're gonna have to say like the minimum then is origin y. Okay, that makes more sense. So then it becomes like, why? Okay. Minimum of this of origin. I think that's right. Oh, okay. We've got numbers now. We'll just plug the numbers in and see what goes down. So we'll say local x min equals origin x. Local x max equals origin math min minus and then origin x. And then yeah, the minimum, and then the minimum will suddenly become. Oh, we could simplify so much of this if we just assume that the origin was always like smack in the center of the screen. But yeah, just doesn't seem right. Doesn't seem right. Whatever. We'll start with these. There'll probably be bugs, but we'll figure it out. So we got all of these, and then we'll go room x equals there we go. And there's our clamp. So if we've done our maths correctly, if I run the engine now and I probe what the current room camera position is, it should be smack in the middle. Or it could crash. That's, you know, that's an option. That's legitimate. What did I change? Did I change very much? I don't think I did. Okay, I changed update room. I added these two functions, which, let's be honest, didn't do very much else. I mean, like, these aren't being called anywhere, so these can't be the ones that are causing it. How does Lua do debugging? That's a good question. I don't think there's actually an inline debugger for Lua. To be fair, I haven't checked. Lua inline debugger. I just have okay, there's like a third-party one that's written in Lua. Huh, okay. I've The thing is, though, I'm not sure I'd be able to actually use it because, like, the main way that I'm communicating with Lua is over Telnet, which just gives me a shell similar to like a REPL inside the current Lua process. So that's kind of currently how I've been doing it. This looks kind of too fancy. This looks like it's going to be doing a bunch of read line stuff, which I'm not sure if like, hang on, like what's in this? What's in this thing? Okay, yeah, it's doing a bunch of peak hole and well, it's not that complicated, but it is. Okay, yeah, it is doing its own special write line function, which may play havoc with. Yeah, I don't know. Maybe later on I'll try and see if it runs in the REPL, but that's okay. Yeah, the issue though is that like when it crashes because of like someone that wrote some terrible C, aka me, when it throws an error, then it can't unwind the stack, and then it causes it to die like this. And usually, like, it throws an error when I do things like call a function that doesn't exist, and that happens surprisingly often. So I think before it hits public consumption, I'll have to eventually figure out what's going on there, but it's surprisingly hard because you don't get any clue about exactly like which bit of the error code is responsible for the problem. Is it math min and math max? Did I invent those? I thought those are real Lua, aren't they? Returns the argument with the minimum value according to that's fine. What possible objection could you have to well, one of these things must be broken. Oh, it's because room doesn't exist. It's because that's the bit I invented. We're actually meant to be using this. Okay, fair point, Lua. You're right. I made a mistake. I made a mistake like 8 times. Right, that's done. It's okay. It's still broken. Still broken. Oh, because of these two. That should do it. Okay, here we go. So we've got our walking. Do our telnet, and now graphics room, is that what I called it? Yes. And there we go, X and Y. It's smack in the middle. Okay, so good start. Next thing that we need to do is adjust what gets... Well, I suppose there are 2 things we need to do. One, maybe we need to like move the actor and like the walkbox, like move all this stuff over here so it's kind of closer to the middle of the screen. Because like from over here, because really what we want to do is change Yeah, we want to change the paths so that they span across the entire screen. I take it back. That's what we want to do. We can get rid of the temporary kind of guide. We just, because now we know that that walking is perfect and these things. But the actual layout, we need to extend this like all the way over here, so that we have like full run to the left and right hand side of the screen. And so what's our test image? How big is our test image? It's 600 by 200. So let's go 200, 600. Yeah, so something like that. So I think what we're going to need to do is I'll need to change the coordinates for all of this. Yeah, I'm still not entirely sure how we're going to kind of make this part, I don't know, user-friendly, for lack of a better term. I'm thinking, like, I don't like the idea of there being, like, an actual, like, downloadable tool that you use, because that just seems like too much hard work. But maybe, like, a web editor where you can upload pictures and then trace out these walk boxes. I'm not sure. I've not decided yet. But let's... Is that... Like, that should be... okay. I may have made a mistake here. No, okay. So we pick all the nodes in this, and then add... Just make this 4. Nice round number. Are these coordinates right? Oh no, they are. Just for some reason it was splitting the difference. Yeah, okay. And then these ones we can snap to snappy. Gonna do a snap. No snap. I've got enable snapping on. There we go. And then this walk box. Yeah, okay, that's also snapped. So this is going to be like the new shape of the path that we're going to have. And to do that, we need to change a bunch of x coordinates in our walk box list. So walk box A is now going to be like 403. What was the 136 and 123. So 103 needs to become 403. Yeah, okay. And then I suppose for all of the rest, it then become a case of like X becomes 403, 437, 431, 393. Okay. That's not too hard. Yep, 393, 431, 437, 403, 403, 437, 437. So yeah, like one of the little things that was kind of like really throwing me about how the Scum Walkbox algorithm works is that part of how it determines which box to move to next, it needs solid, the boxes can intersect wherever they, wherever you want, so long as there's like a solid horizontal or vertical line on the face. And yeah, like if so like for instance, if I change this so that like that doesn't perfectly match up with that, that's fine because there's a solid vertical line. And vice versa if I do it with a solid horizontal line. But that does mean that you can't have like two diagonals that are matching up against one another. And it was kind of not obvious at the time because initially I thought, oh, we tell it like which boxes are connected to what, so clearly that should be enough. No, it actually uses the horizontal and vertical lines as part of the pattern finding sequence, like finding out which is the best point to move to. So that is, yeah, you need those for collision detection. That took me like an entire night of messing around to figure out why it wasn't working the way I was expecting. But that's fine. It's a trade-off. It's okay. Okay, and then we can remove the walkbox overlay. We don't need that anymore. We can move the mysterious image slightly more to the right just to make it interesting. 256. And let's just confirm that everything is working as expected. The camera's not going to move, but we should be able to like by some like very strategic clicking, we should be able to like force the character to move off the screen. Like if I click up here. Huh? Okay. There is a problem. There is a problem with something that I wrote. How did that happen? I don't... Okay. Like, the movement algorithm shouldn't care, though. Why does it care about, like, where the screen ends? Did I type in one of the numbers wrong? Like, that could very well be something that happened. 38 and 1... Did I screw those up? 37. Oh no, that's the very first one. Okay, 3358. Oh, I didn't get the last walkbox attached. That'd be why. I didn't do a good job. So it was trying to save me from myself. Though interesting though that like what it should absolutely not have crashed. Whatever code path that we were exercising caused it to crash, which concerns me. But yeah. Really, ultimately, the solution for that is fix the thing which causes error messages to crash and just instead return an error message. But yeah, not tonight. 3889. Okay, that one's correct. This one needs to be changed to 393. This one needs to be changed to 393. Okay, that should hopefully like connect it up properly. So here we go. Gonna just saunter off the screen. It'll probably take a little while to kind of like walk all the way over to the other side. Ah, there we go. So, okay, we've extended the universe outside the plane of view of the camera, which is something. It's an achievement of sorts. Now we got to get the camera to kind of come along for the ride, as it were. So, got a function here to constrain the camera. Yeah, that's right, Dr. Buck Doctor. We've invented object permanence. It's a brand new concept that's exclusive to this game jam entry. Okay. What we don't have is we don't have any. What we need is a flag, right? We need a flag of some description on the room to say what actor is responsible for moving the camera around. We don't really have that at the moment. We just don't have it at the moment. So we can add that. So PT room. And then we go like camera actor equals nil. And then we could go this. In which case, maybe we should move this at the end. And then we'll go... if... Okay, it's a little janky. It's gonna be like, you know, it's gonna be like just as steppy as the animation, but you know, it'll work. We can add smoothing later. We can might not even have to add smoothing. We could just make it like feel traditionally herky jerky. So here we go. We're trying to cross. Oh, that's right. We haven't actually told anything else to respect the camera. So the camera is moving. It just doesn't matter because everything is being rendered in screen space. But we can check to see if it's actually happening. So if we go PT Okay, so we'll set you back on a little journey, and then if I call this... Huh. Doesn't seem to be working, does it? Oh, is it because I didn't build the engine? No, I did build the engine. Oh, it's because I didn't set the camera. Okay, I didn't set the camera actor. Okay, that's on me. And then... if we were to go... How about now? So now the room... Nope. Still not moving. But if we go camera actor is equal to Ash. So why that not work? Oh, it's because of this? It's this here being a little too... Is it because width and height? Because we haven't set width and height. Yeah, okay. It's because we haven't set that. Okay. Yeah, this is wrong. So this should actually be 600. So we do this. What? Come on. I didn't miss the window, did I? It's not... It's being real stubborn. Okay, let's simulate what's going on. PT current. Okay, room. We've got graphics room. Okay, graphics room actors. Graphics room camera actor. So that test should be passing, which suggests to me that our logic here is a bit broken. Is width and stuff being set? Graphics room width. It's set to 600 now. So, yeah, okay. Let's just... We can... So assuming... I mean, okay, we know this is happening. It's just getting clipped by all this. So then... If I were to detach that so I can read it while debugging. And we go, room equals graphics, room origin X, room origin X, 160, okay. Math.min, room.width minus screen width minus room origin X. Huh. Okay, I've screwed up the math here. Is what's happened. Because it should be screen width minus origin X. I think that's it. Because if we try that again and we go like math min room width minus screen width, oh, but then there's also this clamping factor here. So we have, okay, but we've got room width minus screen width origin X. So we don't actually need this min. I was conflating two things. There we go. So yeah, so that's the leftmost position. That's the rightmost position. And that makes sense. So like if origin X is 0, then it assumes that like the most you can get to the right is the full width of the room minus 1 full screen width. Okay. And then this clamps it. This clamps it between the two. Okay. I've good feeling. Good feeling that that's the correct thing. Okay, so kill this, start it again. Get to walking and graphics room X. There we go. Look at that. We're it's moving the camera. That must be where the path is, and then we're coming back. All right. Okay, so the room coordinates are working. We just need to now adjust all of the blits that we do so that they are in screen coordinates rather than room coordinates. And we've got that function that we did to do that, I think. So we now have this, and then down here in the render, yeah, okay, and rendering only happens if we're in a room, so there needs to be a room for that to work. So basically be table unpack PT room to screen. Yeah, this. I think that'll work. Okay, can't wait for this to just crash and vomit blood everywhere, but yeah, I spoke too soon. Yeah, that's not okay. I misremembered about how table unpack works. Okay. Because what we want, right? Like the function that we did returns two values, and I kind of just wanted to stream them in here, but you know, it's probably easier to just do like local temp x temp y equals this PG room to screen. Oh, and I didn't include the room. That probably would have worked if I just included the room. Okay. It's probably that. It's probably just that. Everything else, there's no trouble. There's no problem. Kill that. Nope. I guessed wrong. That is not the correct way to do unpacking syntax. So we'll do it manually. Temp x, temp y equals pt room to screen, and then all right, moment of truth. I mean, that's okay. It sort of works. It's a little bit more kind of in, you know. Okay, and I also noticed that, like, see how kind of the little overlay sign is happening, because that is happening. Oh, right. Okay, that's because of this here. So I have like one render list which is the current room, and then one which is global. And I think that I've like the text overlays should be in this one so that they don't move when the room moves around. So actually maybe this is fine the way it is. We go object X, object Y, because yeah, like this list is going to be used for like UE elements and that. So that we don't want to move that in screen space like we do with this. Why was the picture not rendering? That was a strange. Like, what happened over here? Why we've got... Also, why is this like all the way on the right hand side of the screen? That seems... did I position it there? Did I really position it like right on the edge? It seems strange. Very, very... Oh no, I must have just put it on the right hand side. But the bitmap is not... The bitmap's not... it's not blitting everything. Now, why would that be? Why would that be? So we've got this back. Is it because... Oh, it could be something in the C code, actually. Like, maybe the C code... No, Dr. Butt, the rest of the map is definitely off to the right. I think it's just because in the C code, there's some... there is some restriction happening there. I should... Did I... Oh, but I got rid of all those. I got rid of all those alerts. Like there's some, like it could be that there's some kind of clipping happening in the C code. Because like here we go. We've got like video blit image, position X, position Y. It then creates rectangle dimensions, and it will try and crop it based on the screen width and the screen height. What is... because like from like the Lua end, Lua doesn't care about how big the image is. Like the only instruction that we give is this draw image instruction, which then passes the pointer to the image data in C and an X and Y position. And this X and Y position is based on whatever we set the offset to be. But that's all managed C side. So it could be that the problem is in C. For the very first time in all of human history, there is a C problem that we've run into. And what have we got? We've got code here, which is, this is all boring. This is just about loading the image. Well, firstly, okay, let's just double check that we're loading it in properly. Yeah, so it's loading in as a 600 by 200 image. And yeah, we created it with the right dimensions. But why does it? I'm guessing it's this crop operation. The crop operation is assuming something bad. Yes. Yes, it would. It would, wouldn't it? Because yeah. Huh. I think we need to tell C about where the graphics origin is. We need to tell C where the graphics origin is, because okay, like here's the issue, right? Here's the issue. It's in dos.c. In this this splitter function, like what it will do is it will do this. And that is basically a crop to make sure that whatever whatever kind of image drawing operation thing that we do is within screen space. Which means that like the data that we have to give to C medically needs to be in screen space. But what I don't quite get is, because like don't we do that? Isn't that what we're doing? Don't we? Like this is converting whatever is in the room into screen coordinates. It is very much doing that. So that would mean that like if we move to the right in the image, then it would say, oh, okay, I want you to render this at like minus 40x. But maybe something to do with this is not quite working. But like this seems okay. Like this is just like we would need to change this. All right, we'll just add this in. We'll add in the terrible blanket statement, which is just going to fill the logs up with crap. But we should be able to see. Oh, but it's got the image path, so we'll be able to see like which is the background. Okay. We'll do it that way. So moving to the right, running out of image, quit so we can get the log. And it's this intro.png. So it starts off okay. But then towards the... It's always just at 0, 0? Oh. Wait, what? No, this can't be right because it should be. We need more information. We need more information in the thing, because this doesn't take into account. And then at this end, we can go. We'd get whatever the crop is. And that would be X, Y, IR, I think. Let's try that. Okay, so doing this, moving into the void, quitting. Okay, so this coordinate is increasing as expected, but then our crop seems to be busted, because it's basically the screen width minus whatever, you know, plus whatever we have in here. Turns out to be this when it should. Yeah, okay, that's not happening the way it should. Because like what's meant to be happening, right, is that this function here, rect blit clip, you're meant to be able to like give it a big old
Are you sure this microphone works? Oh, well, I wouldn't say I aided her. This is on, right? Because actually it was quite a struggle.
You're right, you're not wrong. It's quite a struggle. But yeah, this rectangle, we've got this rectangle is the entire image. This one here is just the viewport occupied by the screen. And then this is meant to... Oh, maybe I'm misremembering how rect blit clip works. This is another kind of function that I borrowed from ScumVM. So we can look at what the original does. I think it was called blit clip. Clip. Why can't I had it before. I ripped... Okay. No, it must be in the rectangle code. Common rect.h. Yeah, this function here. Given the target surface with size clip, this function ensures that blit arguments p destination and p rect are within the clip rectangle. So, yeah, that. So that actually should go here. Because like the proper X position is going to be always relative to the origin. So like the real X and Y position is going to be here and here. Which then goes through this clipping function. So this is room space and this is screen space. But I think that the problem is that room space, we don't really have a transform for, I mean, no, this, like, the whole point of this is that it moves that, doesn't it? Like the blitz source rectangle, yeah, so like this is within sprite space. I get it now. So this rectangle is within sprite space, and then this is the crop that it applies to make sure that it can like render on the current screen. But I don't understand why it doesn't work when there's like, when it's bigger than the screen. It works absolutely fine when it's smaller than the screen, but when it's bigger than the screen, we start to have issues. And I wonder if it's because of code that I wrote. It looks it looks basically the same. Okay. It looks basically the same, but it's... Okay. Rebuild this. Having a look. Have another cheeky look. Quit. And yeah, it really just kind of comes down to like this width. The width of IR is wrong, and that would be, yeah, okay, so this source, so the width of source is now wrong. So source right, yeah, source, so we've got source left, which is being modded here. And we've got source right, which is being modded there. I'm guessing that it's really source right, which is problematic, which is why we can't, we're just missing out on bits. And what have we got? We've got X plus source right. Doesn't help that we're kind of modifying X as well. Like X is like this. The mods that we're making to X and Y, or at least the mods we're making to X, seem fine. It's moving the graphics like further off the screen. It's just modifications to like source right, which I think is busted. Yeah, because we're only like taking things away from the right hand side. And okay, so clip right is always, so it's if right is greater than 320. So if we say it's like 400, which we should know because we've got like the X coordinate and then which is further to the right, and then source right, which we know is going to be like 600. So it's big. So if that's bigger than clipped right, then we just need to adjust it down so that okay. This is wrong. This is dangerous and wrong. I mean, I know it's working here, but it's not working for us. That's the problem. It's not working for us. Okay, I gotta write this down so that my streamer brain can catch up. Okay, so we're gonna go right equals minus, we'll say minus 20 is the X position, plus 600, which is the rectangle width. Okay, if 600 is greater than the clipping rectangle width, which is going to be 320, then we can go or rather we can go like right is greater than 320 minus, so it'll equal 600 minus 20.
Prompt service is required.
Oh, good to see you, Joe Bodie. I apologize for taking too long trying to figure out my maths on stream. It is... oh, it's agonizing. All right. Okay, plus that. Then source right equals 600 minus... yeah. Becomes this again. Becomes 20 plus 600 minus 320, which then become, so 580, and then that becomes 580 minus 320, which is 260. Yeah, okay, and then that's where the crop comes in. What we actually want to happen is we want source right to be equal to minus 20 plus 320. Which I think that's right. Oh wait, no. Hang on. No. Opposite of that. So, what we actually want is for the right-hand side to be 320 minus 20. Yeah, I think that makes sense. So then the question comes up, like, how do we get there from here? Like, how can we kind of manipulate this logic so that it still holds true for like stuff that is like smaller than the screen size, but also works for so we don't get this big old void out here in the middle of nowhere. 320 minus 20. Like, that makes... Oh, but this is the source rectangle. So, but it would also mean changing source left. And we don't really change that now, do we? No, we're just kind of assuming that... Oh no, we do. We change it up there. That was a question. So if we look at what's going on here, so when we so the position of the rectangle, the position of the crop rectangle isn't moving. That could be a problem. Because yeah, like we need to take the crop rectangle. We need to shift it over just enough. But then, then it, or rather we need to kind of adjust this. The clip rectangle stays constant. We need to adjust this so that it should be positive left offset, positive top offset, and then the right offset should be just whatever the extreme of the clip rectangle is. But as it stands now, we're not getting any change on the clip rectangle at all. Oh, sorry, we're getting no... Oh, wait, no. Oh, I'm looking for the wrong thing. It should be really... IR left, IR top. Okay. Yeah, I was looking at the wrong thing, I think. Okay, do this again. Move out towards the void. Yeah, right. So the rectangle, what do you call it? The left and the top coordinates of the rectangle, they're fine. They're doing super well. I'll just double check to make sure that, like, if we go like as far as we can. Leaving aside the fact that the mouse is not dealing with things in room space yet, like, that's another problem that we got. But from a camera perspective, yeah. Okay, so the offset on the image thing is, the offset is fine. It's just the width. The width and the height of the rectangle which are a problem. So why is that? Which part of the friggin' maths is having a go, having a prob? So we know this is correct. Oh, sorry, we know this is correct. We know that is correct. Actually, no, sorry. I don't know. Maybe that isn't correct. Because like this always gets set to 0. Oh, but this is it's okay. It's a little confusing because I think that where is it? So we have X and Y, which are modified in place to, okay, yeah. Because I think X and Y are always in screen space, if that makes sense. So they can only ever be between 0 and 320, this X value. So I'm going to write some comments down to say, okay. So we're going to say constrain X and Y to be in screen space. Crop the image rectangle based on its location in screen space. The source data will then be yeah, okay, we're in a good spot now. So it's just this math here which is wrong. So then, yeah, okay, so we take yep, so we've already done, it's in the correct spot. We then have to modify the source rectangle. And that is we're currently doing that by taking, okay, so we've got the X offset plus the size of the image rect. And if that's bigger than the size of the clip rectangle, then really that should just be, because the image rectangle is in screen space, I'm tempted to say that this should be just oh, but even then though, even then. Oh no, okay, because this is still in screen space. So if this in screen space is bigger than the width of the screen, then we just need to adjust this value, which if we pretend is like this, we just need to make sure that this plus this is at most the width of the screen. So if we write that out and we go, so we go like x plus source right must be at most 320. Then it follows that source right must be at most 320 minus x. And then I think that's what kind of what this stuff up here is meant to do. It's just a little opaque. Minus I think that's right. Let's see if that crashes the game. We should know pretty quick, because as soon as like if if the clipping calculation fails, then we'll just start scrubbing random crap into memory, which generally has a bad effect. So let's try. Huh, okay. What happened there? Did I not build it? No, I did build it. Why it's still having the same issue where it is the width. Oh, it's because I'm trying to change the width, but I'm not taking into account what's it called? Yeah, I'm just assuming that the right hand side is the width when maybe that's not the case. If the right hand side is greater than, or if the right hand side of the image in screen coordinates is greater than 320, then we need to adjust the right hand side of the rectangle so that it is at most this. It's like that seems like it would correct it, but I don't. Oh, is it because is it not recompiling the right thing? I'm a little paranoid about that, actually. Hang on, make clean. Because I don't understand why the new maths isn't picking up on that. No, the new maths is not picking up on that. It is still trying to crop it to that width. Oh, because the left-hand side Oh, but okay, because of... I think... Alright. Maybe... yeah. Yeah, the issue... Like, the X position is correct. It's starting off, like... As we move towards the right, the left-hand side of the image rectangle moves, which is what we want. It's just the right-hand side, which is not dealing with that. Maybe it should be kind of like... plus source left. Like that. I don't like that. I don't like how I made a change to rec.h and then it didn't.
Musical word level 1. Play, but note.
Oh, thank you very much for the follow, Luigi's Fifth Toenail. That is an amazing name, by the way.
Engine damage may occur. Thank you.
Oh, and also Muscarian. Thank you very much for the follow. It's real gripping stuff here. Just me kind of yammering like someone who's lost their marbles trying to figure out what is going on. It's probably because I've just screwed up the make file, and because like all this stuff is in a header file, it doesn't count as being source code, but that's okay. We can force it. Anyway, okay. Will it crash the game if I move off the screen? Oh my god, look, we did it. We did it. We can now move around. Oh, okay, now all we need to do is like figure out what the deal is with mouse over coordinates. And that's easy done. That's child's play. In fact, we can sort that out by going straight into...
Okay, class, time to dissect our worms.
Alright. Back in here. We can go to... Where's the mouse over junk? Yeah, this thing. That's for drawing the stuff in screen space. What we need to do is go back into the game code. The game code is responsible for figuring out what is at the mouse over point. So that would be this handler here, and we need to change oh no, it's the mouse over code. The mouse over code is responsible for telling us where, because actor set walk, I think, oh, maybe we need to do actor set walk as well. Maybe that's also kind of cropped to the wrong spot. There's a few spots. Okay, so yeah, okay, so we have actor set walk, which is a coordinate in room space, so we need to we absolutely need to translate something there. So table unpack PT screen to room. These should be okay because these are going to be in room space. But for the mouse over code, we will need to change all of this junk. Because, yeah, we're doing tests of this. And where do we get the mouse coordinates? Oh, this. Okay. So we'll go room X, room Y, PT screen to room, that. Oh, but we need to unpack it. So table unpack this. No, we need both. What am I saying? Because we have like one set which is global, which is not attached to the camera, which is just floating above everything, and then we've got the room set. So we're going to need to know the room X and room Y separately to the mouse coordinates. So PT mouse to room, mouse X, mouse Y. And then for the stuff which is happening in screen space, then we can go room X, room Y. Yeah, okay. And then all those callbacks should work. Unless, of course, I make a tragic mistake. Mouse, I mean, what did I screw up? Which part of that did I mess up? Like, there wasn't very much that got changed, was there? What have we got? We got this stuff. Oh, screen to room. Oh, I called it mouse to room, didn't I? Yeah, that you know, the function that doesn't exist. Yeah, okay. That could be part of it. No, did I do it again? Where did I... Oh, I need to rebuild it. No, I did rebuild it. Okay. We changed the stuff, we changed some things in C. Those shouldn't matter. We then changed this stuff to do with the test image collision. We then called screen to room. Is it because screen to room has a mistake in it? Oh yeah, because I didn't include the room. That'd be why. That'd be why. Okay, here we go. We're moving to the right. And the hotspot moves with the room. That's pretty nice. Okay, and then it died. Just for a kind of like peak excitement, then it died. But why? Why did it pass away? Why did it was, you know, it was going so well. Okay, click the mouse, do verb nil nil. Where did it crash? Okay, no, it definitely crashed in Lua, because those high numbers mean Lua. Also, the fact that the stack is like absolutely massive with more than 10 IPs means it crashed somewhere in the Lua error handling stuff. All right. Well, in the interim, we can turn this back off because we don't need it anymore. It's working perfectly. Hey there, Ryu Shineka. It's actually not that bad. I'm using DJ GPP, which is like a port of like the GCC toolchain to run in DOS. You can set up DJ GPP inside DOS. I tried that and immediately got bored because it takes ages to build stuff in there. So what I've done is I've set up a cross compiler here in Linux. So I think there's like a very easy there's like a repo which has a script which like will do all of the work and build you a toolchain. So like DJ GPP cross compiler GitHub. Yeah, this thing, build DJ GPP. And yeah, it's like, it's, you obviously, yeah, you know, your mileage may vary if you don't have Linux. Like, I'm sure that there's probably builds for Windows somewhere. I don't know about them. I just ran this to get the cross compiler toolchain, and then after that is basically just kind of down to yeah, like there are definite parts of my setup which I wish were a lot better. Like when I do development outside of DOS, I usually rely a lot on like debugging, like GDB, for instance. Absolutely like indispensable for doing stuff, you know, debugging stuff with C. I've not been able to figure out how to make it work in DOSBox. And you can also build like a special variant of DOSBox which comes with a debugger attached to it. It's never been easy to use, but I have completely failed at getting it to work in 32-bit mode. Like, just very basic things like, hey, can I set a breakpoint on this function which I know is going to be at this address? No dice. I could not figure out how to make that work. Maybe it's down to something like I've got the wrong like CPU setting. So really what I've just been doing is I've been kind of hobbling along, getting the C code to a state where it runs well, and then for the actual, because the engine is basically just kind of like a little bit of C for the drivers, and the actual meat of the engine is in Lua, I've set up a serial console in the engine, which I can now access over Telnet, which is actually I don't have, well, I have to like quit this to open it up. But if I run the engine again, like you can set up DOSBox so that it'll expose a serial port as, you know, as a Telnet port in like, you know, like a TCP Telnet service. So 00004244, and yeah, I've just set it up so that like as part of the cooperative multitasking deal that I've got with going with Lua, like every time the engine idles, like it will just check the serial port to see if there's any input that's coming in, and then I can just do REPL type debugging. So ash.x, ash.y, ash will just print like everything to do with the current actor object, which I've called ash. And yeah, that works really well right up until, yeah, the issue that we keep running into, which causes the engine to outright crash, is that in Lua, what's meant to happen, right, is you can throw an error, and then that just, you know, gives you a nice error message in whatever logging device that I've got set up. Unfortunately, like, however I'm doing it in C is not quite right, and it's causing the entire Lua stack to just implode. But for some reason, it only happens when I make the call from inside the engine. Like, if I try and do it from the REPL here, like, that gets caught properly. Like, if I go error, I done goofed. Like, that works fine. That sends a trace back. That doesn't cause the entire thing to, like, catch fire and, like, vomit blood out the eyes. But when it happens, like, running in line, like, the one place that you'd want it to just catch an error and write it to the disk, it causes the damn thing to crash. Dr. Buck Doctor says, have you seen DOSDev? It's a VS Code DJGPP development environment. It supports GDB, but the debugger can be a little slow to step through. No, I have not. I've not really had... I've not really done much with Visual Studio Code. It is kind of nice that someone's put that together. I imagine that would be a lot... That would definitely be preferable to the situation I've got now. That's probably... That may actually kind of give some of the solution for how to get GDB and stuff working. But yeah, it's really been kind of like... I don't know. I don't dispute that my life would be easier if I probably just accepted accepted the solution someone put a lot of time on into Visual Studio, but that, I don't know, it's not part of my dev setup, so I figured, I don't know, the math is that, like, this on the long run takes less time because I get better at it. But in practice, what happens is that I hit a wall like that stupid crash in Lua, and I'm like, oh, this is hard. Maybe I'll just wait till, like, a future date where I have when I've ported this away from DOS and I can use a real debugger. Honestly, yeah, there's no right or wrong way to do development. It's whatever tool set that you know best and can work quickest with is the best tool for the job. So oh, all right, we have a I kind of wish that I made some more saves or some more commits so that I could maybe bisect the thing that's causing it to... Like, that time it, like, just died immediately. Why did it die immediately that time? Because, like, if I... Oh no, it's just always dying now. It's like any kind of... So hotspots are fine, but as soon as I try and, like, click the mouse, it does not like that. So what code did I add? Which... That wouldn't change the mouse over. It would have just changed... It wouldn't have changed the camera binding. It's got to be like this screen to room or room to screen. It's got to have, like, screwed up one of those calls. That's correct. That's also correct. Oh, maybe it's in the game code. Something I did in the game code that's ganked it. I set the... Okay, so we set that check. Feels like we didn't really do that much. Oh no, we did a bunch. We changed the walk boxes. We changed the size of the room. We changed all this crap. Oh, I should have saved. I should have saved. Oh my god. This table unpack. Because I didn't set the room here. That's why. Yeah. I keep getting, like, pranked by my own... Maybe this is a sign that, like, I should always, like, make this operate on the current room. Because it doesn't feel natural to have to say what room I'm talking about It should just be whatever the current room is. Yeah, okay. Executive decision. We're doing that. We're changing the API. Because honestly, we're dealing with screen coordinates. It should, like, the only room that we'd ever care about is the one that is on the screen. And we can only have one of those. So, we're executive decision time. We're changing this to be the same as how the loop thing works. Not PT current room. Actually, no. What am I saying? We don't need to make it crash. We can just make it. We could just make it lie. Just make it lie. Pretend that everything is fine. Oh, it uses a fork of GDB, which only works with DJ GPP symbols. I mean, that's kind of, I guess, part of the cross-compile thing. Hey Summer, how's it going? We've actually gotten quite far. Ignore the crash. That's just temporary. We can move around. The camera moves. We've actually got like the walkbox code working. Like it's all coming up Millhouse. But I'm just now like fixing like a terrible design decision that I made. Which is when converting from like room to screen coordinates, I stupidly said, "Here, you get to pick what room."
I think women should be able to play any sport men play, but hockey is so violent and dangerous. Look at Millhouse's teeth.
Please don't look at Millhouse's teeth. You'll regret it. Actually, do we have the line? Do we have the line?
Everything's coming up Millhouse.
There we go. Okay, now I got to go back and like undo the terrible mistakes that I made. Screen to room. So, don't need the current room anymore. That's implicit. Room to screen. That's it. Gone. Do I use that anywhere else? No, I don't. Which then means this should now work. Oh my goodness. Kyle and Era, welcome. You came at like just the opportune time that like everything is now basically good. Here we go. So here's what we've done since last... I didn't fix all of it. Oh, did I hit rebuild? No, I did. What I was going to say is that everything is working. We can now like walk around on the screen. The screen now moves with the character. Like a whole bunch of stuff got sorted out. Then I decided, oh, I don't like the API that I set up for like mapping room coordinates to screen coordinates, and I changed it. And then like a like a dunce, yeah, okay. So that's fine. That's sure. Okay. Where did I Oh, this unpack? Is this unpack statement bad? Where could make clean make? Just start again. You can take one step, but then you must deposit 40 more quarters. Yeah, that'd be the smart way of going about it. That'd be the like, yeah, if we were making this for what's it called, King, like, no, King doesn't exist anymore. It's now just Microsoft, isn't it? Anyway, if we were making it for them, then it would probably be like that. Oh my goodness, what? Okay, I've missed something. I've missed... Okay, it's coming. It's coming, I swear. We're gonna actually get, like, a working thing. Alright, we just gotta be methodical about it. Okay, this stuff is fine. That stuff, all good. This is a little sketchy. PT screen to room. Like, that should no longer need the room involved. In fact, we can test that. We can test if PT screen to room is working. So, open up Telnet, because we've now got like full debugging going on. We go PT screen to room 200 by 200. Gotta figure out like why sometimes print PT screen to room 200. Yeah, okay. And then if we go print PT room to screen like 200. Yeah, something's not quite right about... Yeah, okay, and then that correctly... So, those are both working. Those are both, like, sending the right values down the... Oh, interesting. And clicking on the hotspot doesn't cause the crash, so it must be just the walking code. And, oh, okay, and now I've broken the camera. The camera was working, but it's not working anymore. Okay, so where's the camera code? The camera code... room.x... Oh, current room.x. Oh, no, it's because I did a really bad job. That's why. I got rid of the there was an argument called room. I thought I replaced it with this, but in fact, I just did a sloppy job, and I didn't type out the rest of the stuff that I needed to type out. We're at the streamer brain point of the evening where everything makes sense if you just do it quickly without thinking. Okay. This is it. This is the run. Why do I snooker myself like this? Why do I snooker myself like this? Where did I, okay. This is all... Did I mistype a name? Actually, hang on. We'll try that again. So if we go back into here, like, does hotspot movement work? Okay, hotspot movement works, but it does not move the camera, which is disappointing. But the camera should be moving. Because like, we've added all of this stuff in here to make the camera move. Based on the position of the actor. Oh, hey, Robot Spacer, how's it going? We're getting... oh... Yeah, at this point, I'm just kind of... I'm regretting not doing a commit slightly earlier to the code, because now, like, movement... Yeah, we've got an issue where it's causing the engine to crash every time I try and click, which implies that it's crashing because of this code here. I don't understand why... Okay, let's just do it manually. So, local temp x temp y equals pt screen to room event x event y. So there we go. There's no more unpack, which I'm suspicious of unpack. Maybe unpack doesn't work. There we go. Temp x temp y. Yeah. So sorry. That's... Is that built? Okay, that's built. Run DOSBox again. Oh, it was the unpack. The unpack was cursed. Does the screen? Oh, but the camera... Okay, the camera is not moving. So there is a walk path. I can show... Like, the walk path kind of looks like this. I don't have a graphic on screen to demonstrate it, but essentially we've got pathfinding working, so you can see here that, like, based on where I click the mouse, the character will try and meet that, and then if I go to the other end of the U, it'll walk around the other side. So the real question is, why did the camera stop working? So it should be, the camera should be being updated by all of this, except like the walking stuff is fine. It's just these values here which are not being updated properly. When less than 20 minutes ago they were fine. Kyle Nero says, totally new question, but do you have stack traces in Lua? Yes, we do have stack traces in Lua. The issue is that because of me, writing bad C, instead of getting a nice stack trace when it happens in the main thread, it causes C to crash. But for instance, like the other thing is that I've set up like this debug terminal here, and if I do like a crash in the debug terminal, which is part of the main thread, like if I do like error mistake, like that'll work fine. That'll give me like a full stack trace back, and it won't, more importantly, it won't crash the engine. So it is oh, we're close. We're so damn close. Okay, so what I'm gonna do, we're gonna move Ash all the way over here. So we can look at Ash's position. Ash X is now 312. So the room, which is called graphics room, what's the X position of that? It's 312. So the issue is that everything is not being shifted over by the right amount. So the room position is correct, but the code that we have for like moving all the graphics around, I think might be wrong. Which is not update room. It's in here. It's in here, isn't it? Yeah, which relies on room to screen. So maybe room to screen. Yeah, room to screen must not be working. But I don't know why. Because yeah, I did spell PT current room correctly. And I didn't meaningfully change how room to screen worked, aside from just fixing what the fixing what the room to use as the source point was. So why is it dying? Why is it not working? Okay, PT, and it was room to screen, wasn't it? Yeah. Okay, PT room to screen. And if I go like 600 or 420, yeah, it's like it's always falling through for this, which would then do the the not adjusted version of that. So wherever, okay, let's test these things. PT current, sorry. Hey, Bloody Cactus, yeah, we've definitely made progress. So we've got walk boxes working. We did have like camera movement working as well. Yeah, so like this is what the walk box is meant to look like. And yeah, like the walk box code was like a massive pain, because I took that basically directly from Scum. So like this is exactly how like Scum does its walk boxes, and it was just like a big ordeal, like initially porting that algorithm over to Lua so that we can use it there, and then testing it to make sure that it didn't screw up. And so now essentially if I can click up here, the engine determines whether or not that it'll determine, hey, you've started off in this box here. It follows the chain of which boxes it needs to walk through in order to get there, and then it will take the shortest path in direct space. So like quite complicated. There's like about 500 lines of code responsible for that. But now that we have like all of that, and we've got we've got text, we've got oh yeah, that's right, we've also got like delays now for walking. So for instance, if I click on this hotspot, it'll then queue up a verb, and then like I can like abort it by just walking over here. Or alternatively, if I just click it and then wait, it'll eventually then reach there, trigger the verb, grab the input, which I can then skip. I can also skip past, like I can do like a cutscene style skip. So if I start this and then hit escape, it'll then just fast forward through all of the commands. But yeah, well, it's we're making good progress, I think, for the engine side of things. And then like, okay, like all of the back-endy stuff is pretty kind of complex and technical. What I'm hoping for though is that like once the engine gets in like a stable enough state, people should just be able to write really simple types of game logic. So like, look here, like the script that I've got currently for like clicking on this hotspot here, like all it does is it like grabs the input, which then hides the mouse cursor. It then makes the character talk. By default, it will just do that based on, it'll wait for like however long the text is. It then does this little kind of thing here, which does a little sweep on the PC speaker. And this is all cooperatively multitasked, so other stuff can be happening in the background while this is going on. And then for the demo game, like, yeah, there's still quite a way off before we can get like a full demo game, but I have been like going through and preemptively writing like all of the dialogue and all of the kind of various bits and bobs. So yeah, the intent is, yeah, first release the engine, which will probably happen like, so yeah, for the game jam, we're just going to release the engine, and then I think maybe like another week is what it's going to take to make the demo game in a good enough position to release as well. So anyway, last issue is that why... last issue I think for tonight is going to be like figuring out why the camera is not moving. And I'm a little kind of... I don't kind of get it, because... It could... Oh, actually, no. It could be that, like, both of them are, like, breaking because of this check. Because it's just a pass-through. So, if, you know... If the screen isn't moving, technically both of these are correct. But... if this check is wrong, then we got troubles. Is it just underscore current room? I mean, that feels... Yeah, I don't know. I really wish I had a Lewis step-through debugger at this point. Because that would be, like, this would be just child's play to, like, just, you know, just do one thing after another. But that's okay, we can pretend. We can pretend here in our debug shell, running over telnet. Yeah, I know, Carlinero. Like, it would be really nice to have a step-through debugger. I did see that there was a package, like a Lua package for it, but I'm not sure if that will work over telnet, which is kind of the... you know, this is how I'm kind of accessing the internals of the engine, and that has certain limitations. Like, you don't... I mean... I don't know, like, things like kind of when you're using a console application, especially like a POSIX console application, that you generally get a bunch of things like exposed through term cap and other mechanisms like that, whereas with telnet, you don't really get that. You get a line buffer, so like what I'm doing, you know, like all this stuff I'm typing in now, like none of that is being sent to the engine. That only happens when I hit enter, but it's not quite like read line. I have not figured out how to kind of you know, do fancy things like multi-line buffered input or anything with it, and that's just because I haven't figured out how to do more complicated terminal interactions through that. Actually, no, there's an easy way. Crap. You know, when you don't have a good debugger, you can always opt for the cheap debugger. Well, you know, the best debugger is the one that you have. Oh, there we go. I think we found our problem, which is that this check is not working properly. But I'm not sure. Is it because like current room does it, like it's not in scope? Like that could be it, actually. That could actually be. If it's that, I'll be quite cross. Anyway, we'll it's like, where do I define PT current room as a local? It's probably it's like all the way down here. Oh my god. All right. So I think that probably it'll be solved if I add the functions here. Because yeah, Lua is quite picky about like whether or not something like scoping when it comes to local. Like there's a lot of kind of like weird quirks, like for instance, if you declare a variable inside a function, that's global by default, unless you say it's local. And likewise, these top level ones, like local means, I think it only starts existing after the first time you say local. So it's yeah, but I'm guessing it's that. I'm guessing it's that, which is wrecked us. Anyway, let's see if the camera moves. Oh my god, it's happening. The camera's moving. We're walking across the invisible walkbox. We're walking behind the DOS Smells mural. We're able to like click things. The text is moving around with the screen. Yeah, we're it's good. It's a good spot. Good spot to be in. Yeah, all right. Okay. So we can add camera to the list of things that we've done. Colin says, ship it. We got a few more things. We got a few more things that we need to kind of do. A big one is switching rooms. I've not even thought about how we're going to kind of deal with switching rooms yet, but we're probably going to have to in a bit. And I also, I got to do a lot more graphics than just this. This is just placeholdery stuff, but yeah, like I can show you kind of the outline of the walk cycle that I've got yet. I've been doing some rotoscoping for the character graphics. So tools, light cube. Oh great, it crashed and lost everything. Do I? Oh, and don't tell me that Wine doesn't like the recovery page. Hang on. Oh, I opened up the menu at the wrong time. Hang on, let's try this again. This time I won't be hasty, and yeah, okay, here we go. So, yeah, recover all of it. I'll figure out what it is later. And then, okay, home, me, development. Oh yeah, I made like a little logo for the engine, which I think is nice. This is, yeah, it's a pixel version of, yeah, a Parenti lizard, which is the name of the engine. So there's that little thing. Where's the actual? Oh my god! And I have to like go through the entire. God, Windows can be so tedious sometimes. Really wish I could just. I need to figure out, one day I need to figure out how the favorites thing on the side works, so I don't have to like scroll through the damn thing every single time. Originals. Walk R? Oh no, stand R, sorry. So yeah, like here is the so yeah, like the original shot is just a, you know, a photo, and then over that I do this trace, then we do the kind of color gradient fill, and there we go, sprite. So I'll turn off onion skinning. So I have a walk cycle. I just need to color it in. Just need to kind of like overcome what's called just the inertia of like, oh, what if I do a bad job? Oh, what if I have no? Just need to kind of suppress that gag reflex, go ahead, do the coloring in, and put that into the engine. But then that will but yeah, I'm thinking that like even if I do run out of time, I could just do left and right and maybe get away with that. But hopefully I'll try and do like up and down as well. Like honestly, I'm quite happy with how this turned out. For like, honestly, this is like the first time that I've properly tried to do pixel art, and I've got to say, it is a hell of a lot easier when you have a dedicated tool which is designed for pixel art. Like previously, I was just using kind of like, I don't know, the GNU image manipulation program, which is many things, but it is not good at pixel art. It's kind of lousy for pixel art. But yeah, the next, I guess really then, aside from a couple of like administratory type things with the engine, I just gotta get my haunches in gear and start making sprites and dialogue and wiring them all up. Yeah, this I'm gonna so we'll probably have like another stream. We'll have one next week, and it will be hopefully a lot further along. I'll be able to kind of do like maybe the last bits of engine related work in that. I'm gonna try and keep the spoilers to the game a minimum. It's not gonna be very big. It's gonna be like 3 rooms, but it's nice to just keep the content out of the dev streams and such. Oh, Carl Nero says, I tried using a GNU imp, and yes, it was unpleasant. It's not great. It's got its quirks. It's better than nothing. It's better than I don't know. I don't really know that much about Photoshop, so I don't have the muscle memory to complain that it's not the same as Photoshop. So there's that. But yeah. So that's kind of where we are. We've got most of a working game engine. Oh crap, the other thing that I need to do with game engine, which I've not really done yet, is wire up the sound card. You know what? Maybe I could spend a little time doing that. Because I've got PC speaker audio, and that's just handled by the timer. But what we don't, the other thing that I want to get going is not really ad-lib music, but OPL3 music. And to do that, so I have the code. I've got the code in here for the Reality AdLib Tracker player. So this was like originally C++, and I ported it to C because the rest of the engine is C. But I have not thought about how we're gonna wire this up. Because it would be nice to have something very similar to iMuse, where you can like define. I mean, like it's tracker. This is tracker music, so you can define sequences and loops. But it would be nice to have like it set up so that you can set it. You can do like latched transitions, so that when you move out of one area, you wait for the first bit of music to finish playing, then you play a cue, and then a transitionary cue, and then you go to the next loop or something like that. No, I'm not going to do it tonight because it's getting a bit late over here. But yeah, that I'll try and have that done for next time so that we can. I don't know. Hopefully, we'll just spend more time on just non-spoilery content things on the engine, unless there's other things I can think of. But I think we've actually got enough. We've got enough here. We've got camera movement. We've got animation. We've got hotspot detection. Like that's more than enough to make a test game. Like yeah, the only missing components would be the music player and some better code for like switching between rooms. We can do it manually, but I don't know. Maybe the approach will be I'll just do it manually in the test game, and then based on how unpleasant it is, I'll add in some nicer API stuff for it. But yeah, I think that I might call the stream there because it is midnight, and I need to, I don't know, stand up, walk outside, touch grass, do that kind of thing. Who is online? Who is online and doing things?
Song. Press that note to kick that song.
Oh, thank you very much for the follow. Oh my god, sorry. And it scrolled off the screen. Hang on. Apologies. I was like juggling the page. Bixafew, sorry. Thank you very much for the follow.
Prompt service is required.
And thank you also for the follow, Marianne0918. It's yeah, it's good to have you here. Okay, we're raiding now. It's happening for real this time. Let me just fight a little bit with Twitch's fantastic raiding interface. Okay, so I guess we'll go to like another creation stream. My friend A Good Pete is making some more horrifying stream artwork. So, oh, and it's apparently this is streamiversary. So we're just gonna raid A Good Pete. But thank you so much again for watching. I'll see you all next time very soon. Let me just set up the raid. Good Pete. There we go. Alright. I'll see you all, I guess, same time next week then. Okay. See ya.